Hello, everyone. Welcome to ZaranTech. Did you know that AI can improve business productivity by more than 40% and help companies make faster decisions? Welcome to our channel. In this course, we are going to learn about SAP AI Core and SAP AI Launchpad in a very simple and easy way. SAP AI Core is a service that helps businesses build, train, and manage AI models. SAP AI Launchpad helps users monitor, control, and manage AI projects from one place. Today, many companies use AI to automate work, save time, reduce errors, and improve customer experience. That is why SAP AI tools are becoming very important in modern businesses. In this training, you will understand the basics of SAP AI Core and AI Launchpad, how they work together, how to manage AI workflows, deploy AI models, monitor projects, and use AI services inside SAP environments. This course is designed for beginners, students, IT professionals, and anyone interested in learning SAP AI technologies. By the end of this course, you will have a clear understanding of SAP AI tools and their business value. So, get ready to start your learning journey with us. Let's dive in. Hey there! Want to learn how companies use AI in SAP systems? Our SAP AI Core plus AI Launchpad course is here to help. You can learn anytime at your own speed on our platform. In this course, you'll learn all about SAP AI Core and AI Launchpad. It helps you build, manage, and run AI models easily inside SAP systems. Our course covers everything you need to know, from simple concepts to advanced AI tasks. It's created by experts who have real industry knowledge. Your trainers are skilled professionals who have worked with SAP AI tools for many years. They're here to guide you and clear all your doubts. And don't just listen to us. Our learners really enjoy this course too. Students from different backgrounds found this training easy, useful, and great for improving their SAP AI skills. Best part? The course is budget-friendly. You get strong SAP AI training at a price that works for most learners. Ready to become a SAP AI Core plus AI Launchpad expert? Join through our page today. And to learn more, visit ZaranTech.
SAP AI Core and SAP AI Launchpad architecture. Basically, in this, we will be learning on this one. So, fundamentals of SAP AI architecture. So, first of all, let's understand what is SAP AI Core and what is SAP AI Launchpad. These are the main components. Okay. First, understand the very important thing here. SAP AI architecture, especially in the modern SAP landscape like BTP, S4HANA, it is not just AI on top of the SAP, guys. So, this is what this is. We can say it's a layered enterprise grade architecture which is designed for scalability. Not only for scalability, it is designed for governance, it is designed for real-time decision making. Okay, a lot of things will come, when we talk about this particular SAP AI architecture. Okay, so when you break down this particular architecture, the core idea of SAP AI architecture is what? It connects business data like SAP and non-SAP, the AI models like ML and generative AI, the business processes like automation and workflows. These are all it connects. So the total goal is what? You are turning the data into intelligence and intelligence into actions, right? I'm again telling, we are turning the data into intelligence and intelligence into actions. That's quite important. Okay, then what are the key layers of this SAP AI architecture? So what can be the key layers here if we are going to do that? So that is where everything will start. Okay, now I'm going to explain you what are the key layers. In that layers only, this AI Core and AI Launchpad will come into picture. Okay, let's detailedly understand what is that first of all. So we will be having total 5 layers. Layer 1, 2, 3, 4, 5. Layer 2, layer 3, layer 4, layer 5. Okay. So this is a total towards the thing here. So the layer 1 contains data layer. Okay. Layer 2 is your AI and ML layer. Layer 3 will be your application layer. Layer 4 will be your automation and orchestration layer. Layer 5 will be your experience layer. Getting this? Okay. So data layer. First of all, let's understand what is data layer. This is where everything starts. What everything starts? Like SAP S4, HANA transactions, finance, logistics, all these things. The SAP success factors, Ariba, all these things. External systems, basically the APIs, third-party apps, all these things. These will come as part of, when I'm saying everything starts means. And technologies, like if we can go for SAP HANA Cloud, Data Fabric or Data Intelligence. So these are the main technologies which will, like come into the picture. The key concept from this is, it's like more like of clean, contextual, real-time data. This is critical for AI, the data layer. That is the whole thing about this. Okay. So when you go to from here to A and ML layer, so this is where the intelligence is created. Means this is what the are as I told, right? The main components for this is your AI core and AI launchpad and AI generative AI hub. So these are your main components. Okay. So what happens here? Here in this AI and ML layer, we will train the ML models. You will deploy the AI services. We will manage all the LLMs and monitor the performance also on top of that. Like think of that, it is like a engine that runs the AI models. Okay. And there come your next one, which is your application layer, right? So in the application layer, what you will do? This is where all the business users will start interacting with AI, like intelligent voice matching or demand forecasting or chatbots, whatever is a so-called the SAP or SAP Joule is one such example which I can quote. Like the key idea for this is AI is embedded into business apps and is not separate. Okay. So that's what the idea behind that. And the next one will be your automation and orchestration layer, which is not this connects the AI decisions to actions like SAP build process automation, integration. So these are the main tools for that. So here what it will do, the AI will detect the fraud, trigger the workflow and alert the manager. So without this layer, AI is only for insights, not execution. So this layer is much important for you for this automation and orchestration. And there comes the next layer, which is your experience layer, which is the interaction layer. Here, users interact with AI. How? The question will be answered there. Like how users will interact with AI, like through Fiori apps, conversational AI like Joule, dashboarding, insights. These kinds of things will be experience. That is why the last layer is called experience layer, this one. Okay, so what is the mode of interaction here? Like the most of informational, you'll ask the questions, analytical like insights, transactional like doing the actions, navigational like moving across the apps. So these are all the different types of modes of interaction that we are going to do with this. Okay, and not only that, you have the cross-cutting capabilities of this architecture. So what do you mean by that? Cross-cutting means like, governance and security, the context awareness, human in the loop, ML lab, these are all such things. So governance and security means more of role-based access, like data privacy, AI explainability. These are all things will comes under your governance and security. When I'm talking about context awareness, business context from SAP data, like using the more of user roles and history kind of things will be there as part of the context awareness. And human in the loop, I already discussed in the last two modules. So human in the loop, HITL. So approval workflows, exception handlings will be handled in this particular block. And then MLOps, one of the other thing where we go for model versioning, monitoring, and retraining. These are the common things which will go as part of this one. Like already I have told you an end-to-end process for this example also. I just want to re-quote you. Let's take a real use case again. The scenario of invoice fraud detection. If it has been given to us, what is the first step we'll go with? Data will come from S4HANA. Then AI model in the AI core will analyzes the patterns, and then it will go for detecting the anomalies of that, and it build the process automation. This tool will trigger the workflow, and manager will get a alert via Joule, and human approves or rejects the things. So this is a complete full SAP AI architecture in action, which we can discuss on that. Okay, so this is how. So now one question will be always matters to us. What is that? How generative AI fits in it? Fits in it. So with generative AI, natural language queries can be answered, document summarization can be done, code generation will be much simpler, and intelligent co-pilots can take care of a lot of activities, as you're already seeing in many websites and many of these organizations as well. So basically, our SAP is also powered by generative AI. Now it's called as SAP Generative AI Hub. So Gen AI is not a separate, it's integrated into the same architecture. Always understand this. Okay, and remember this. Now, why this architecture? Whatever I told, it's clear, I know. But whatever the architecture I told, why this architecture matters? What is the specialty in it? So if there is no architecture, can't I go and do something on these systems? No. The answer is a big no there. Because without this structure, AI becomes siloed. Nothing. It was quiet. And no governance on top of that. And very importantly, no real business impact happened to that. So with SAP's AI architecture, what happened? You can bring the scalability, you can bring security, it can be the process driven, and it's most of enterprise ready, which is very important for us, right? So a simple thing here is like data to AI, AI to apps, apps to automation, and automation to experience. This DAE, we call it as DAE. That's DAAAE. Okay, it's a 5 layers structure, simple to remember as well, right? So this we can more further elaborate more diagrams and everything, but I for your understanding, I gone with all these things. Now going back to our PPT here, which is skin here, right? So onto this, you have, what do you have? You have two tools, right? One is AI Core and another one is AI Launchpad, right? AI Core, these two actually, these are two confused looking like, but like when they play very different roles in SAP AI architecture. So think of AI core as the backend brain where AI actually runs. That is why we always call AI core as an engine. What it does, it will execute the ML models, it will run the pipelines, it will handle the scaling, a lot of things it will do. Okay, like AI is an AI core will be an engine for you. Okay, so you can deploy a fraud detection tool. AI core runs it on the live data. It outputs the predictions. A lot of things it will do on top of that. Okay, whereas AI Launchpad can be a control tower or a control room for you. Like AI Launchpad is the UI where you manage and monitor the AI. Like it does all your viewing of the models, monitoring, tracking the versions, managing the deployments, governing some access. Like simple. AI is a, I told, engine is the core. Launchpad is nothing but your dashboard plus control panel. Okay, that's how you have to think on in a simple example. Okay, so how they both work together? When you build a model, you will deploy it into a AI core, and you have to go to AI Launchpad, monitor, runs it, logs it accurately. You have to see the accuracy on top of that, and you can manage the life cycle on top of that. So AI Core does the work in the back end and Launchpad shows and controls the work in the front end. Similar. Like, okay. So this is what you have to understand about the core and Launchpad. And stopping the screen again for a minute, just have a look of the definitions one more time. Now, fundamentals of SAP AI architecture. Now, if you consider this fundamentals, we are seeing specifically few things here, like the tenant-aware services, isolations, maintaining of tenant namespace, and all these things will come into picture. There's obviously because in 2026, a tenant is strictly mapped to BTP sub-account zone ID. The isolation with assets, workload, and all these things happen, and main tenant namespace is being allocated further. All right. If you go for resource groups also, there is a virtual isolation, right? It's like more of, I told you just an example also, right? We'll go with what you call defining of user groups, resource groups, use cases, the scope, everything will be there as part of that. So this is all a kind of like a resource group virtual isolation you can consider. Workspace level, yes, there's a UI command center wherein which the connection management, global user assignment, these are all things will be there. In a short while, I'll show you the practical part also. There you can understand these things. And defining resource groups, these are more of virtual collections where you configure, deploy, and artifacts, all these things. This is mainly for all the core instance we'll try to do it. But artifacts is one of your resource group, they cannot be seen on access by other. Like it's a sandbox environment for execution, basically it is for. So environment setup and architecture and fundamentals of SAP AI architecture only. It's a more of entitlements. You'll create the instance, you subscribe the launchpad, and all these things will be there as part of that. Okay. So you need some security keys. You have to generate those keys. These key contents will be there, like your API URLs, your URLs, ID secrets, and security will be also be provided there. More of authentication will be there. Either it's been your token, your API call, your modern alternative authentications or OAuth 2. So any tokenized or untokenized authorization can be also, you can see. In the BTP environment, basically, we will be managing this and we will take care of that from there. Okay. The next one. Now the summary and checklist, you can see here, just as an architecture check, provision check, and security check, which we will be doing on top of this. So a short unit only. Yes, we covered this. Let me show you practically also what is this. So if you go to this account, sorry, the first one, whenever you want to, this is a BTP global account, whatever you are seeing, this is a fresh, you can say it's a BTP global account. So you will see the sub account, right? In the global account also, you can see onto this global account, this sub account has been assigned. Okay. If you open the sub account, let that load, right? You are seeing here entitlements, instances, right? If you go to the entitlements, this is what I told. This is the main entitlement which you have to have it. Either free or this is the standard version, which is a subscribed version. It is showing you as unlimited. AI Launchpad. Similarly, AI Core. These two have to get it. So from where you are getting these two, when I open system has already had it, that's okay. But where are you getting from it? I'll tell you in a while. These are entitlements where you need the services to run here, and you can see the commercial information, whether it is free or standard or extended versions, whatever you can use on top of this, you can see that. And then if you go to this overview tab, basically, the instances will be there here. This is where also you can do a Launchpad integration in Launchpad. I'll just show you this here and go open. So before that, let me show you one thing. If you go to the main global account, you have the boosters. Onto this boosters, what you will do, what we will do, let me show you. You can prepare an account for ABAP development. So these are all the boosters. So what I have to do, we have to understand as per our lab activity to set up your AI Launchpad and AI Core. See, this is nothing but you have to run these two boosters. One is setting up your account for Launchpad, another for Core. But while you have to run this, you should have the admin permissions for it. Then only you can run. Not everyone can run it. Go to here, start it. So if you start it, now see here, it is showing you either you can directly create a sub account if you are a BTP admin, or else you can select the sub account. See, only this is a wizard based activity wherein which you go one by one. For example, I go to the next step. It will automatically see this is already my sub account, right? This is my sub account which I'm seeing here. So this sub account and the organization name, it will get it from it, and the space that we have showed, it will be automatically get. And the next step is to review and close it, finish. That's it. This will create the AI core part, which is an engine for your system. Then you can go to the launchpad again. This is your launchpad. How this looks like, you can see here a small diagram, a components of the launchpad. Additional resources, if you want any, you can see here. So so you can see all these launchpad based discovery center and everything here on side by side page. Okay. Now, all right. So now we can go to here. Just simply start this. Same thing, selecting of sub account. Again, same thing will be added. So see, you do not have the security admin rights to access sub account trust configuration. So as I told, you should have it, but yes, it's not a big deal. I will just show to you the org and space will come, review it, say, okay, that's it. So both installations are done. As simple as that. Okay. So now what you have to do is just go into the main one. Now you have already seen, right, in our global account, go to the account explorer. This is what your Joel. This is what that org name now it has been automatically taken. This is the space name which it has taken. This is your API endpoint, default API endpoint. Okay. So like this, you can see this is under US now because our region is under US, East Virginia, AWS. So automatically this will change for everyone, the API endpoint based on the region you are going to select, right? Accordingly, the endpoint will be changed. So now here, this is how those will come and sit in your environment. Okay, the AI core and AI launchpad. Okay, so like this, once after that, you can just go to here. Keep me sign in, say continue here, sign out in Chrome, continue here. Now I'm showing you how AI launchpad looks like. I told you, right? AI core is your backend and launchpad will be front end. This is how. So you have to, these are the resource group which I told you in the PPT while discussing that. These are the main ones. Okay. Once you create the resource group, onto that, like a tenant ID will be there. Just click there and all this menu will get activated. Left side. I'm holding the screen for a minute. Please have a look on it. Right. Now you're seeing here the model library, grounding management, chart, orchestration, everything here. This is all. There will be three important items, guys. You can see workspace is okay. This is a normal workspace which you are seeing here. That's okay. But the main ones are these ones: the generative AI hub, AI core administration, and ML operations. Okay. What is generative AI hub in this launchpad? What is this? So you can say this is not the main. This is the main component. I can say this is a central service in SAP BTP. This basically gives you access to generative AI models, a lot of things, it will generally talk about this particular item, whatever seeing here. So this is very important item that you are seeing here. So this is a major thing that will gives you lets you in for a lot of activities that you want to do here, like model library or grounding management or anything. Okay. So inside SAP AI Launchpad, first of all, when we come to the model library, this is where you will see all the available LLMs. Like GPT models. See here, these are all those ones only. The GPT models, other provider models like Claude, all models will be there based on this. Is now seeing all your Claude, lead, and everything. No, we can see till we have the complexity and everything as well here. Okay. And this is all SAP managed models also. And what do you do here is actually browsing the models, selecting with which model to use, checking the capabilities like text and embeddings, all these things, and the app store for AI models. Like majorly, that is what you have to do. Okay. And majorly grounding management, which is all the other important thing that you have to understand. Grounding management for what? That is for connecting your business data to AI. Okay. Grounding management, the second one I'm talking about. Why we need this? Because in the model library, I'm telling about the LLMs. So LLM don't know your SAP data by default, right? So what do? You upload some documents, you connect some data sources, you create the knowledge bases, you enable the RAG. RAG means what? Retrieval augmented generation. So AI fetches SAP data plus some answers. That is what. Next one is your chart. So what is this chart? It's a ready-made chart interface for testing the models. Like you can talk to AI directly, you can try the prompts, you can validate the responses. Like it's a playground like ChatGPT inside SAP. Chart is for. And there comes your prompt editor. What is prompt editor? Where you design the prompts. Like if you want to write structured prompts, if you want to add variables, if you want to test responses, if you want to summarize the invoice text, invoices, all these things, right? You can do some prompt engineering that basically you do in the prompt editor. And there comes your next item, which is orchestration. So what is orchestration? So it's a very powerful and often misunderstood. So it chains multiple steps together, buddies. Like, when a prompt is there, it goes to API call and it will goes to another prompt and to result it. That's how it works. For example, if you take extract invoice data, are we going just for extracting? No, right? Then you have to validate with SAP API. Then it will generate the summary. Like, you can think like it's a workflow for your AI logic. Okay. There comes next prompt management. Okay, this generally prompt management will store and reuse your prompts. So what it do? It saves the prompts centrally. The version controlling will be there. It will share across the apps. So it's majorly important for your governance and reusability. When I want to talk about more into specific. Okay. And then there comes your optimizations. This one. So what is this optimization will do? It's of more like it improves your AI performance. Like it includes your prompt tuning, cost optimization, latency improvements, better output with less cost kind of things it will do as here, as you're seeing that here. Okay. And then administration. Basically, it control and governance, the last one. So when I'm saying that, it will be an access control, it will be a model permissions, it will be API configurations, anything. So it is enterprise critical security and compliance. Now the question is how this all will fit together. Please think on that. I'll give you an answer in a minute. So how all this fit together, I'll just show you simply here. Say this. If you go to this, first one is what I told. You have to choose model. Right? Model means what? You will go for model library. I'm going with the tool comparison also, guys. Whatever I showed you. And then you have to add business context. Right? For that, what you want, you will do grounding. Then you want to design the prompt. Then what you will do, prompt editor. Then is that enough for you? No, right? Then you have to chain the logic. With what tool you will chain the logic? Orchestration. And then you will test it through what? Chart. And then we will save it as part of the prompt management. Okay, one saving, are we good with that? We have to still improve, right? So for improving, you will use optimizations. And finally, for controlling, you will use administration. Okay, so whatever I have told you right now, see here, onto this part, all these tools, the simple thing I have taught for you. Okay, so understand that, guys. The entire menu is basically a toolkit kind of thing. For what? To build, to test, to manage, and to govern your generative AI inside SAP. That is what the generative components which you are seeing that now. So next one, you can see this one here. You can see AI core administration and ML operations. Okay, ma. So what is this and what these individual things can help you with? Now, SAP AI core administration, as I'm seeing here, this is like, it's a more of setup and infra. That is what it was being told in the demo also for you. The setup I already showed you. Now we're talking about what the infra layer. What are the important things here? The first one is JIT repositories. What are JIT repositories? Whenever you want to connect your JIT, GitHub or GitLab, all these things, then you will go for JIT repositories. It will majorly store your ML code, pipelines, and configurations. Why we need it? Because AI core pulls code from here to run the jobs. That is an important thing. Okay. And then we have applications where you will define your ML application, logical grouping of models and services will be done through it. So think like it's like a project container for you. And then you have Docker registry secrets. Wow. What is this Docker registry secrets? 1 second, let me reshare my screen. Okay. Now you're seeing here Docker registry group, Docker registry secret. Okay. So this one, what are all the Kubernetes kinds of things that you generally do, right? Anything that whatever that you're going for Kubernetes level, whatever you're trying to make it for that, like all these things can be on the Kubernetes, whatever the so-called Kaima based coding and Kaima based services that we are trying to do that, right? So those are all comments written in this environment. That is where your Docker registries will come into picture. Okay. And there come your resource groups. Okay, there are many things are there. One by one, I'll explain you. The resource groups, basically, you have seen the moment when I started here, right? This is the resource group, right? In the before the workspace level, you can see here. See, these are your resource groups. So even you touch this also, that also the same thing. So resource group here, basically how you control compute power and isolation for your AI workflow. This is all generally, it's like more like your engines kind of things, which will initially start here something for that. So without them, your heavy models can consume everything. So no cost control, no environment separation, nothing will be there. So that is why these are very important in administration. Then next. Then next you have object store status. Okay. Sorry, object store secrets. So these are basically, if you can see, you have a type of S3. That means the bucket will be there. Like this is a storage. Okay, like in AWS, how you go S3 bucket and all these things, right? Similarly here also. Before, first of all, what is object store means? It is like a storage used for your data sets, your model files, and for your output region. Okay, that is your object store, like SAP object store, AWS S3, which I have quoted for you. Now, what are object store secrets? Nothing but these are your secure credentials, which can be used which they will be stored in AI core to connect to that storage, basically. So they typically include your access keys, secret keys, endpoint, URLs, and all these things will be there. Okay. Why these object stores are needed here? Because AI core job, sorry, your, what do you call, it's like a secure login that you need it for your storage and everything. That is the reason why you need it. Okay. And then you have your general secrets, generic secrets, which will be there. Not for normal things that you're going for, general security things. So altogether, this will help you in such a way. Okay. And then next. Yeah. Now we are on the ML operations. right? So because the moment when you go and in the workspace, if you're not selecting this, those but get default, they won't get signals activity, all these things. All right. The next one, ML operations you're seeing here. It's more of your all AI activities, quick status news will be there here. And in scenarios is where you have to do high level, what do you call the use case definitions, like fraud detection, demand forecasting, think like a business problem containers and all these things is you will be doing for the scenarios. Configurations are quite common. You define how your model run here, like the parameters or environment settings or pipeline configs, whatever you want to say, all these things will be into that model only. Okay, you can see there are 4 model configurations are there, for example. Let's say if you go to the orchestration ZaranTech. So in this, you can see all these in facts and everything, artifacts and everything. All right. So then you can for executions. Executions means actual runs of your model. Like, it's a training run, interference run, like model training will be started and it will show logs here accordingly on top. Okay. And then deployments. Make model available as API. That is the main confirmed deployment. Like you can see all these are deployments, which is the configuration status of what you can see here. So which means after deployment, other apps can call your model. Like fraud detection API endpoint I told you, right? Similar way. Okay. And then schedules, automate the runs, daily model training, hourly predictions will be there for schedules, which you can use that. Okay. And then you have data sets, which you can manage the training and testing data. And models, as I already told, the stored train models, which you can already see. We have to add whatever we have, you can add those models here. And finally, the result sets may be there. Result sets are your output of executions. And other artifacts are nothing but supporting files. Whatever the supporting files and everything, it will be there. Right? For example, if you have a code in Git repository, you will create some scenarios, you define the configuration, you run the execution, and you store the model, and you deploy the deployment, and you schedule the automation. That is how it generally. But how this relates to generative AI? For example, if you go for a prompt in AI Core, that is ML pipelines. In generative AI Hub, if it is LLM call, in AI Core, it is a model execution. In generative AI Hub, it is a chart. In AI Core, it will be called as training or interference job. Similarly, for it is here, the orchestration, there will be a pipeline. So like this, there will be a analogy will be there, the relation analogy. So I'm just writing it for you for better understanding here. Let's draw a table here. This says generative AI. This will be your AI core. Okay. All right. So here, these are prompts. These are ML pipelines. If these are LLM calls, this will be your model execution. If this is a chart, this will be your training inference jobs. If it is orchestration, then this will be a pipeline. All right. So you can see one more thing here. Like if this is a prompt-based AI, this is a full ML engineering. Okay. Think like a factory. Generative AI Hub like a customer interaction. AI Core will be your factory floor and Launchpad will be your control. Simple. Okay. So in general cases, if you consider like, any step-by-step hands-on, like also anyway, we will do one to exercise as part of the other modules also. So you have to always connect Git repository, guys. This is very important. For the AI core administration, right? Git repositories are very important. Okay. So you have to add your GitHub repo model. That means you have to create your model. You have to add some folders and files on top of that. And then you have to create the application. Okay. whatever the application name will be there. You have to create scenario, create configuration. In the configuration for ML operations configuration, that is the most important step. Like you have to define the Docker image. You have to make a command to run, and the input output paths also we have to define it. That is pretty important. Like if it is an YAML file also, for example, image, your Docker image will be there. Command, you will write some Python or train.py something. So now where you will link it? You have to link it to Git repo basically, or any parameters, any environment variables. Okay. Then you can run the executions for the ML operations executions, whatever you want to do. So that is what. And finally, you have to register model and deploy the model, test the model, and finally you have to schedule it. That is how generally you go it. The simple path, I'm writing it for you. Just observe the total engine flow here. Right. We can go like this, the full flow recap. Git. Application to scenario to configuration to execution into model and then to deployment. So real use cases like S4 HANA sending invoice data, AI core prediction of risk, build process automation triggering the approval. These are all these different things. Okay. In this, you might involve in some cases the wrong, common mistakes can be done. Like wrong Docker image paths will be there, or sometimes it might be missing the dependencies, sometimes incorrect commands, sometimes no resource allocations. These are all these common mistakes that we might do as part of that. So please be aware of that and take care of those mistakes also when you are not doing that. So the moment when you deploy a model in AI Core by running it in a container, you are registering it, you are exposing it as an API. Okay. Simple example, if you want to give you a ready-to-use sample zip also, I give you that report. How that ready-to-use repos also. Let me show you that. The repo structure, everything. So this is how your report structure should look like. Getting this? Just have an observation on the screen. Then you can write something on all these things as well. Just putting the hanging on screen for a minute. Please have a look on it, guys. All right. So that's it. So this is how you will do this is how what is the end-to-end thing about your SAP AI architecture, AI Core, and AI Launchpad.
Hey, you know, ZaranTech now offers SAP corporate training. That's right. Train your workforce in SAP with our comprehensive program. We offer customized courses, certified trainers, and hands-on labs for both individuals and businesses. Our standout features? Bespoke training, fully configured servers for practice, in-house materials, and a dedicated LMS. Plus, get session recordings and 24/7 support. From functional to technical modules, we have got it all. Choose ZaranTech for SAP training and watch your team excel. Learn, upskill, succeed with ZaranTech.
We will be discussing about the core concepts of this MLOps and GitOps integration basically. Okay. And then onto this, we will see the containerizing a Python ML model and push to Docker history kind of, practical scenarios as well. So whatever is possible in this, I'm just try to show you. But we get a complete understanding about MLOps and GitOps integration. So basically, so this is what we are going to understand about this. Okay, let me open this one. Right. So anyways, I'll explain you in the meanwhile. what are all these things that we can do on top of this as part of ML ops and ML and GitOps integration. Okay, so let me explain on this. Let me share my screen on this. Right, so let's discuss this part, which is MLOps and GitOps integration. So we have to understand MLOps versus GitOps. Okay, so in SAP AI's perspective, I'm speaking about whatever all to in this context. So MLOps, machine learning operations. So in SAP AI, this is more speaks about building, training, and deploying your, monitoring these ML models basically. So managing the lifecycle in SAP AI Core is one of the core things here. So you can track, tracking the experiments or versions metrics, all these things will be there. So model lifecycle management all together, like you can do like that. So whereas GitOps, when you can consider, it is like, it is using the Git as the single source of, like either intra or deployments, where as a combination, which you can define it as a code. So automated deployments will be there via pipelines. So you can think deployment plus environment and engagement or management will be there on top of this. So now actually where this fits in the SAP architecture, the core components of all these things, as I already told you, even we talked about MLOps versus GitOps, the SAP AI Core here, it will execute. Let me come by component. So SAP AI Core, it executes ML workflows, okay, where this includes all the training. Training in the sense means the machine training plus inference. Okay, and then we have SAP AI Launchpad, which will be like it's a UI to manage the models and scenarios, and SAP BTP, where you can call that as platform that is hosting everything for that. Okay, and then GitHub or GitLab, which is like source control, like it's a GitOps engine. Okay, so altogether, these are the components which will be fits in the SAP architecture. Now, how MLOps plus GitOps work together? That is what the question, right? So, if you let me go one by one, step by step, like how these will work together and what are the key integration concepts and what is the benefits of doing this and what you have to avoid. So, every single thing I'm going to explain you on. Okay. So, for MLOps, basically, we understood now what is MLOps and what is GitOps, and we understood where this fits exactly. In component wise, we understood that, right? So now for as a combination, when this works together, so this is how MLOps plus your GitOps work together. So what is that? The first one is code and pipeline definition in Git. That is the first one. So I'll explain it one by one. And then once code and pipeline definition happen, you have to do Git trigger, CI/CD pipeline, deployment to SAP AI Core. This is more of like Git ops style. MLOps lifecycle in AI Core, basically. And then model serving, which is an inference. And then monitoring and feedback loop. So these are all the 6 steps which you have to go when you are doing this combination of MLOps plus GitOps to work together. So on the code and pipeline definition in the Git, like here, we can go like, it's like a store. It's like an ML code kind of thing, like Python, TensorFlow, all these things, Docker files, workflow, YAML, training, serving. So these things will be. So basically, you can go for then you can initiate your pipeline definitions with YAML, for example, API version, the kind, the metadata, the name of it. This is where the GitOps Entry point will be there. Then you have Git trigger CI/CD pipelines, where here you use tools like GitHub Actions and Jenkins, where here you will build the Docker images, you will push the container registries, you will validate the YAML files and all these things on top of this. Okay, that is one of the important things. And then coming to the Git trigger, once it is done, then you can go to the deployment of the SAP AI Core, where in which the pipeline calls AI Core, which is the API. It will deploy the workflow, and AI Core executes all the training jobs, stores the model artifacts and everything. Okay. And then MLOps lifecycle in AI Core. Like, it will handle automatically, like, experimenting the tracking, model versioning, metric logging, retraining workflows, all these things will happen. And model serving, it will deploy the trained model as an endpoint. Okay. The deploying the trained model as an endpoint, which will consume via all APIs, SAP apps, and all these things as part of it, like S4HANA, CAP apps, whatever you call it. It will be all doing from that. And monitoring and feedback loop, it will be of more of monitoring. Like, you can go drift, accuracies and failures and all these things, where this will trigger the retraining pipelines via JIT. So this will closes your MLOps loop. Like all the two loops, which is the combination of MLOps plus GitOps, this is how they work together. Okay. So this is a step-by-step process. Anyways, we will see some practical part also on this. Now, when you are doing this, the main thing is what? Key integration concepts, right? So what is the main key integration concept when you're going for MLOps and GitOps? So there are certain things which you have to understand. Mainly 4 important things we'll call it as. One will be JIT as a source of truth. You can do it. Second one, declarative AI workflows. Third one will be containerization, which is critical. And the fourth one will be CI/CD plus AI Core integration. Okay. So when you go for this one, the first one, which is JIT as a source of truth, everything will be stored in JIT. Like, it's ML pipelines or the deployment configuration or the infrastructure definitions. So one important thing you have to maintain here is no manual UI deployments. Getting that? So that is the most important thing you have to understand. Okay. And then, so when I'm saying this, it's a production grade systems. Avoid this basically. Okay. So no manual UI deployments. Okay. And then declarative of AI workflows. So instead of you saying something to AI like, hey, run this script, you will define this is my desired ML pipeline, so ML pipeline state. So which is where SAP AI Core executes it. That is called declarative AI workflows. Okay. And then come to containerization, especially for Kubernetes and all these kinds of things, like Docker. So this is very critical. So every model runs inside the Docker. So which is what? It will ensure the portability and reproducibility as well. Okay. So that is the importance of containerization. So you have to understand what? Every model runs inside the Docker. I'm writing here. It's an important point. And then the final part, CI/CD plus AI Core integration, the pipeline flow. So you can see like JIT commit will be there, CI/CD will be there, Docker build will be there, AI Core deployment will be there. Okay. So this is all about that. So now what are the real SAP use case? Very important for training, I'll tell you. The most common one, I'm going to give you one example always, because that is the one which you can more correlate to. If you go for invoice fraud detection, let's say if you can take the flow, first of all, what happens? Developer, and let me write this use case also so that this will be helpful for you. The use case, invoice fraud detection. Okay. Developer first, what he has to do, he has to update the model in JIT, right? And then JIT pipeline will does what? JIT pipeline will build the image and deploys the training workflow. That is the next step. After JIT pipeline, in AI Core, it trains the model on what data? SAP data. All right. Then model will be deployed as API. And SAP S/4HANA calls API during the invoice processing. Okay. If in the entire, this is the 5 steps. The first one is updating the model, build the image, deploy the workflow, train the model, and again deploy it as an API. And now SAP S/4HANA call that API during the invoice processing, all done. In case of anomaly, when whether the anomalies are getting detected or not, how you can do that? If it is detected, what happens? This, if anomaly is detected, then you can trigger the workflow automation. That's it. Nothing more than that. All right. So what it is combining here? It's combining AI Core, it's combining JIT, it's combining SAP process automation at action layer. All right. So now what are the benefits are you getting by combining? So now we understood what is MLOps, what is GitOps, what are the key factors, what is when they combination work together, what are the integration concepts of it, a use case also we understood. Everything is good. Now, as a whole, what are the benefits now by combining this both MLOps and GitOps and SAP? As you have seen, one of the prime benefit that anyone can get is the full automation. That means no manual deployment, faster releases. That is the important thing. And second important thing will be your governance and compliance, which is a version control of models, which will do like kind of audit trials via JIT and everything. And then we have reproducibility, which is like same pipeline, same result. And then we have scalability, which you can easily handle multiple models. And then continuous learning is one of the other important benefit where the models will be retrained automatically. Okay, so these are the prime. There might be many that when you go by case and everything, but these are the prime global advantages that you get when you combine the things of MLOps and GitOps in SAP. Okay, now during this process as well, there might be some common mistakes or common issues might arise and we have to avoid. Well, one of the first important part is writing here. So avoid using AI Launchpad for manual deployment in production. That is first important thing. Okay. Then this is not versioning data sets. Okay. So your model reproducibility fail. So AI Launchpad is good for testing, not for enterprise automations. Okay. And then ignore the monitoring here. Ignore monitoring where because model drift kills the performance silently if you start do that. Okay. And then tight coupling with SAP backend. Always remember that expose the models, whatever you have, with the via APIs only. Okay. Now let's observe this. All right. So all in all, so this is one thing. So yeah, there are some advanced architectures also there. What makes you sometimes stand out further. Like you can extend this with feature stores, vector DB plus GenAI by GenAI Hub, agent-based orchestration. So these are the things which will be there. So the moment when you do joule triggers AI core pipeline dynamically using some context plus kind of business data, whenever you do such kind of things, right? So that all things comes under advanced architecture only. Okay. So the simple mental model you have to always keep in your mind. GitOps is nothing but how things are deployed, and MLOps are nothing but how models live and evolve. So together, they can give you a control the pipeline. That means Git controls the pipeline where AI core executes the intelligence. Okay. So that is what you have to learn about that. So let me show you one of the other thing also here. All right. So let me explain you as we have already onto this stage. Real GitHub repo structures. Let me show you the how they looks like. I will explain you how CI/CD pipeline, all these structures are explaining you. I have a copy of it, so let me do it for you so that you'll understand more clearly. These are all real GitHub repo structures, in which we can see the SAP AI Core project. Okay, so this one is your nothing but CI/CD pipeline. So Docker model container will looks like this. Under source, you have this training script bot Python. These are all Python files where you can see all the inference logics. AI core training flow, this looks like, and configurations look like this, So I'm just keeping this model for you. Just have a look on this. Okay. So after this, we have Docker files, which you can see because AI core runs only containerized workloads, I told, right? So how that workload look like? I'm giving you a sample file of it. See this sample file, everyone. So this is containerized workload. So see how it is. Looks for you. Okay. So you have to use from Python version, work directory, copy, and then you run your pip install, and then cmd command, Python and try py folder, right? And then we have the next one, AML file, which I told you, which is for training work, how it looks like. So this is the core of MLOps. Just find the file here. I'm just giving you the file name. Understand the file. You have the version and everything. I'm just locking them for a minute. Just understand how the file can be written. Right? So here we see the scenario, we see the image, your Docker image, and then the arguments. All right. So then if you go, I'll give you the file, how you can description, or you can say the inference file format for YAML inference serving file. This is how YAML inference file. So this exposes your model as an API endpoint. You can see all this with port and everything is there. Just have a look on it. There comes next. What is that you have to go for? GitHub Actions, which is a GitHub pipeline which you have to get for it. So your GitHub Actions pipeline looks like this. This is where all your GitHub will happen. So if you see, you have written all the GitHub name of the deploy, on push, which is the branches, the jobs you're going to deploy for it, the steps to implement it, what is the Docker image, what is the push image you're going to do, how we are doing the deployment. Everything we can write like. All right. So with this, you will generally do all these kinds of things. Usually when you're doing this as a deployment at all, right, you have to first create your core setup. Core setup will be done by your admin. Then you will start building and pushing the Docker images, which I have told you how to do that. The register scenarios, upload the workflows, and then trigger the execution. For all these kinds of things you can do as part of that. Okay. So you can see here that we have this one also. Okay. So now let's do this containerize a Python example here. Now let's go to the close this one. Go to this one here. Selection here. Like this. All right. So now to do this example, containerize a Python thing. So this will be your overall flow to for this example, whatever you want to demonstrate. The overall flow will be like this. First Python code, and then Docker image, and then you have to do Docker registry, and then Git repo, and then AI core workflow, and then execute. Okay, ma? So this is what you have to do. First, create a minimal Python ML model. Let me open this one. 1 second, let the system open it. Okay. So I'm on Mac. For the same similar things, we can do little later on the other things also. So we will do one thing. We will install some of this homebrew, install the Python, install Git, install the Docker, and then we'll create the ML project. Okay. And create files and everything, and create the Dockers also on top of that one by one. I'll show you all this is simple exercise onto this one. Now let me show you. I'm opening terminal. So this is one such tool that we need, homebrew. This one, give me a moment, guys. So into this, we will do this one. I'm sharing this. I'm just loading this file here. So for terminal thing, so you can see this is actually doing all these command line interfaces and everything. Just hold on. It is doing the installation for homebrew. Net that's still installing command lines. It will take a little time because we are installing the required tool sets for any of your system. Because if you're in code, you have to go for Microsoft Word based thing. This is some Apple, so it will going something not relevant that as well. Okay, just wait. After this, we have to install Python, install Git, because with the practical scenarios, I have to show you everything on this. Then we'll install the Docker steps. Then we will create the project folders, files, and Python things, requirements. Create the Docker files. Okay, we'll build the Docker image, run the container, and in the Docker Hub, we'll push the image. So then the image will be in the cloud. Okay, so this is all you have to understand as part of this. Let's go one by one. No hurry here. Okay, so let me first of all complete this part. Okay, so this is done. Now let's check the version one more time. Okay, that's okay, fine. With the latest version only. We install this Python. Because the homebrew version is still not ready, right? That is why it has might be showing this. Let's copy this commands as well here. Oh, let's see this brew version. Should show. Yeah, now it's working. See, the new version is showcasing. Now install Python. So this will install the Python now. All right. So once we install the Python, we are good to go with the Python also. Okay. So now we'll go to the next step after this. As I said earlier, so for Python also we have versions are there. So let me give you the Python version here. Python is 3.9.6, so which is working. Now install the JIT. Okay, so install the JIT is also there. So to know the JIT version, copy the JIT command here, understand what is the JIT version. So it is the latest version, I think so Apple JIT 154. Then now, once it is done, you can install the Docker desktop, which is very important on this. So after installing Docker desktop, you can see whether it is still running or not. Okay. So for the Docker desktop, I'm just, touching and showing you one thing. This is the Docker desktop. I'm just doing it here in this website. Okay. We can just choose plan and get started. Sorry, I'm just for the security, I'm just switching off the stop ship for 1 minute for the main purpose. All right. So now I am into this Docker now. So Docker desktop we can download now. Yeah, that you can see here. Launch it. No, but we have to see here the Docker is running. Just wait for that. Okay, now we can go because all your chip M2, M3, that is all this one. So go with Apple Silicon one. Similar, you have to follow for the Word also. So this is a Docker image. See? So you can see the Docker will be there, verifying it's installing that. Open that. Accept. So this all little takes time, guys, because you have to do a lot of things here. Allow that and proceed to Docker desktop. Hello. Okay. So you will see a Docker thing similar like this. Okay. Your running container show up here is what it is telling. It's good to know. Then next, what is that we have to do? We have to just check the Docker version in the same terminal. Open the terminal here, paste it, and see here. See the Docker, which if your Docker is installed successfully, then this will show you clearly like this, that this Docker is in completely done. So there is no issue for your Docker. Whatever you have done, that Docker is been done. You can see the version of the Docker as well. Okay. So now here, the next part is once Docker is done, now all the main parts are done. So what are we did here? We have installed initially Homebrew and then install Python, install Git, install the Docker desktop. Everything was done, all the latest versions. Now create the ML project for this in the terminal itself only. Okay, now I'll give you the command. Let's say make directory ML project and change directory ML project. Okay, so we're under ML project only. Now we'll create the touch command one file system. Okay, so then we will open that particular one. So this train.py was opened. Okay, that means the file is open. So now just put this code here. I have an existing code here. Just unlocking the screen for little while. Just understand this one and then put after save and close it. Okay, and then closing this. Okay, so after that, now create another file called requirements.txt. Okay, guys, and then open that. And in that also, we will do something on this. Simple. In that, we'll write one simple command here. File, save, file, close. Okay. Now, we created the initial files, whatever in the Mac way we can create. Now, specific to Docker in the Mac specific, I'll create a Docker file. Okay. So, for creating the Docker file, I'm writing here, touch Docker file. And then again, open the Docker file. Command touch is for creation, open -e and that file name will open the relevant file. And whatever the content you want, you can keep it in that like this. Just observe what content I kept there. Okay. So now after this again, this one also expand, file, save, file, save, and close. Okay, two files open now. Okay, let me only this one. File, save, and file close. Okay. So now the Docker file has been created. Now we will build the Docker image. Now what I'm going to do here, we will replace our username with Docker Hub username. Like this. See here. For the first time for this will take some time, guys. Yes, I was just trying to this one, so I just kept mute. So you can write this build T command. Okay, username. Let me writing my username like Kabo here. Okay, and then you can keep the ML model like this. Enter. So first this will take some time. It will run the Docker build. Okay. Last step is you have to run the container and like Docker Hub login, push the image. These are thus pending with us. With this, we can complete this exercise. Yeah, this is done. So what is saying? Debug this build file, ZaranTech can help me with this is okay, fine. All these are okay. Now we can run the container test. You can do this one here. So one second, let me give here. You can go for this. Here you can write table name, or else we can do one thing. You can write Kbo ML model 1.0 and enter. Okay. So you will see that the model is trained or not from this. So you have to allow the terminal. Okay, you will see the model will be trained. See, run Docker and help is there. So you can just run like this and it will allow you, and you can push the image. Let's say Docker login. The login sometimes, if it is problematic, it will not take you that Docker login. Please be careful of that. Okay, login, is it succeeded or what? Yeah, this is succeeded. See here, the login is succeeded. Now push your image. Same thing, that username should be properly there. I think so the username was wrong because I have given another username. Yeah, I got it. Just hold on. And give this username B/ML model 1.0. What it is saying? Tag does not exist. Yeah, because I have not done. So let me rerun last 3 steps one more time here. Like first we'll build the Docker here. Okay, so in this, I'll give the username as Docker username only. Okay, by ML model 1.0. First of all. Okay. And then you can do run it. Docker run. Same for the username. In between, we are not able to do this. B model 1.0. So this image should be there. Yeah, there may be image issues. We can check from your side also. That's it. No, once you run like this, log in and push the image, the Docker image will be pushed. Okay. Now then that image will be in the cloud. So this is how you have to see that whenever you want to, we have from the Mac to Python code, Python to Docker, Docker to cloud image, we push it this. This is the foundation of any SAP AI Core, guys. Okay. So confirm always 3 things: whether Docker build work, container ran successfully, image push Docker Hub. These are the 3 important ones which you have to check it before you go for AI Core Hub. Okay. You can involve BAS also, but honestly, that is the not first thing. This is the main one which you have to understand. Whenever you want to, go for this kind of, that is what, in the exercise also, why I showed you all these things. This is what containerized model push to Docker, onboard Git plus Docker into core. So this is how, once we are done with this, automatic core will pick the Docker and we can take it out. So that is a lab activity which was being intended here. So I have showed that. Okay.
Hey there! Want to learn how companies use AI in SAP systems? Our SAP AI Core plus AI Launchpad course is here to help. You can learn anytime at your own speed on our platform. In this course, you'll learn all about SAP AI Core and AI Launchpad. It helps you build, manage, and run AI models easily inside SAP systems. Our course covers everything you need to know, from simple concepts to advanced AI tasks. It's created by experts who have real industry knowledge. Your trainers are skilled professionals who have worked with SAP AI tools for many years. They're here to guide you and clear all your doubts. And don't just listen to us. Our learners really enjoy this course too. Students from different backgrounds found this training easy, useful, and great for improving their SAP AI skills. Best part? The course is budget-friendly. You get strong SAP AI training at a price that works for most learners. Ready to become a SAP AI Core plus AI Launchpad expert? Join through our page today. And to learn more, visit ZaranTech.
We will be going to learn about deploying the custom models via ML workflows. Okay, so let me share my screen before got any lag into this. All right, so deploying custom models via ML workflows. All right, so what is this? We have seen a couple of things on that. So we'll understand in this also how we are going to SAP AI Core use for ML workflows. They learn basically on how this go workflows handle training and serving the pipelines, and then structure the templates, and then manage the databases and model artifacts through the topic stores, and then triggering the training executions and transition models in the deployment stakes. All these things will discuss one by one. So first, one of the things why ML workflows matter. So what ML workflow deployment means? See, deploying custom models via ML workflows is a general core concept in SAP AI Core. Like it is more like similar MLOps platform. Since like when we are going with kind of new approaches or with a repeated or experienced approaches, when you're going with that, you should need these things to know. People who are very new, they have to know that also. So first important, why it matter and what actually it means. Because first of all, what ML workflow deployment means, I'll explain it. Instead of manually deploying models via UI, we define everything in an ML file. Like it's a Docker image, a resource, or inputs, outputs, or the execution logic, whatever you so called. So AI Core generally reads that ML and runs your model automatically. So that is why when ML workflows, when you are running, it serves as the operational blueprint for your ML tasks. Okay, that is first point. All right. And then the next one, there are version decisions will be there. They will ensure all the reproducible execution across all the environments. Okay. And not only that, for separating the orchestration logics or like for defining the templates and steps when you want to bridge the gap between the custom and production workflows. So all these things, they need this ML workflows, and that is why they matter. So even on a big picture, if you go to like our regular Notepad, I'll just tell you some of the important things there as well. Let me show you this. Just to give one guys, the Word file is getting open here. Right. So now here. So onto this. If you see, like to our ML, is the ML workflow. First of all, we have to train the model, and then Dockerize it. And then we can push this to registries. And then create ML. And then we can deploy via AI Core. Okay. So you can do anything of, while you're creating this, we can do a kind of different things also on top of this. and we can make different ideologies, the way you want to put it for requirements. Okay, it all stands with your model, first of all. What are the Python build model you create, right? First of all, you build the Python model, and then we have to create the Docker image. And then you can build and push the Docker image, create the ML workflow, and then add the scenario. Like SAP AI Core specific, you have to add the scenario. Okay. And then you can create the execution template on top of it. Then you have to push this ML to Git repo and register repo in the AI code, and finally you have deployed. So I'm giving you this exam complete step-by-step process. Whenever you follow, you can follow this from here. Okay. So I'm going to write this now one by one clearly for you. First step will be create your model. You can write through from Python. Okay. And then create Docker image. You can build and push the Docker image. Okay. And then we can go for create the ML workflows. Okay. We can add a specific AI core scenario of possibles for that as well. Create the execution templates. And then you can push ML to Git repo. Okay. And then you can register the repo in the AI Core, and finally deploy. These are the steps for it. Okay. So now going back to the PPT. So that is what the thing you have to go. And go workflows in SAP Core. So what are the Argo workflows? As it is the core, SAP AI Core uses all these Argo workflows under the hood of the to run your ML jobs. So you don't interact with Argo directly, but your ML files will be actually Argo workflows. They are actually Argo workflows. So simple understanding, no confusion. Think like this. Argo workflows are nothing but your engine who runs pipelines on Kubernetes. AA Core, as you know, it's a managed layer on top of the Argo, and your AML is nothing but the instructions for Argo. So when you deploy a model, Argo will execute it. So now what Argo workflows actually do, they let you define the multi-step pipelines, dependencies between the steps, parallel jobs, container execution. Like for example, you say step 1 train model, step 2 evaluate, step 2 deploy. Who will tell? Argo will tell. So what is the basic Argo workflow AML thing will go here? With a minimum structure, it will go like it contains some files like main, train step, evaluation step, and based on that, it will go one by one. Okay. That's how it will work for you. And you can use this in AI Core, like this AML is wrapped inside scenarios, execution templates, executions, all these things will happen, right? So if I want to quote a real example for SAP style, and inside AI Core, your workflow will be usually referenced like, with some AML kind of thing, which I have already shown you in the earlier. So AI Core intentionally converts that to Argo flow. Okay. So you must understand what are the important things. You can start with the step of AML entry point with some main, go for some templates, with the sequential DAG and everything. And then after that, you have to work on it. Okay. So what happens internally is very important. From AI Core, you can create an Argo workflow, and from there to Kubernetes pod spins up, and then Docker container runs, and then it will logs with output stored. Okay. But you have to understand one simple point here. Why Argo is powerful? Because it is scalable, which is runs on Kubernetes. It is having a good parallel execution mechanism. And not only that, retrying mechanism will be there, and it's a resource control for CPU and GPU. Okay. You might face some errors also with identification and all these things. Please be careful for that. So rest all, this is what, you have the screen on information about this. Just have a look on it. One more. I'll just keep the screen for a while. Okay, so everyone observed this, right? Go to the next one. So there are two template types in AI Core, which workloads use training and serving template types. So workload templates manage pair jobs and model training, as you see here. And then we have these serving templates, which will define the continuous inference services for the trained models. So both will use the ML, but they serve for different underlying operational purposes. So you can understand this distinction, which is essential for full ML lifecycle design and everything. Okay, on top of this. And then training templates, tells SAP AI Core basically how they can execute jobs, because they include all the metadata for scenario mapping and artifact descriptions basically. So it might be a specific definitions, they might define execution steps. Sometimes the templates also parameters, the reusability will be there, which I have explained to you. So these things will count for you when you go for the anatomy of the training workflow template parts. Okay. And then what are the required metadata? As you know, all the annotations, AI Core workflows, and their IDs, specific metadata templates, all these things are the required, for your training templates. When you want to structure the YAML header, I already told to you, just an example also I told to you, there will be a metadata contains some technical name, and then the top section will have some template identity, and it will consist some name and distinguishing IDs as well. So which I already told to you, same section it will follow. When you want to define the spec section, it defines the workflow actual execution logics basically, because there is an entry point further. Like you can say for Argo also, let's say if it is Argo, we can give entry point, like semicolon main, which is nothing but your entry point further. That's what the entry point means. Okay. Which execution graph to start. Like, each task is equal to one template there. So like this, you generally do this spec sections. So workflow process also, it start with scale, staging, repeatable operations, isolation, and then modularity benefits one by one like this. I'm holding the screen for a minute. Just have a look on it. Okay. And then next one, containers inside training templates. So whenever executing some steps, right, like it might be AI Core runs on the packaged environment. Sometimes you remove the external dependencies for the reproducibility. Sometimes you have to switch between different training images. So these are all the different containers would be there based on the requirement. You have to run inside training templates accordingly. And these are the input parameters and artifacts like you are managed by imports, workflow object stores, and some of the execution logics, they will be folded as your inputs to pass runtime values and files. So output artifacts and model persistence level, yes, whenever you want to generate the outputs with all the models and their execution outputs, so you use this. So here also you can have templates, and they will specify the container paths. And from the models, you will get the files, and which you will survive after the container terminates from the other only, because the container will not hold everything for the long time. The moment when it is done, it will exit. So the things in a container will be picked up by your model. Okay. And all your persistent outputs can be registered, reviewed, deployed later based on that. Your future deployments will be completely on the model artifacts. Okay. So for that also, you have model deployment, version control, self specs, and managed services. So these are the required metadata for serving the template. Just have a look on. Okay. So structuring the serving spec. So what are the serving spec I told, right? It will have some input, scaling, container details, as you said. So the model will have the artifacts of it, and then all this configuration, replica behavior, inference containers, and all these files you can put it. And this will dictate the ML, like both deployment and runtime behavior. So this configuration dictates exactly how models can become live services for that as well. Okay. Next. So the predictor section describes the inference container serving requests for this, because storing predictor design guarantees deployment success and runtime stability. So that is the reason we will use that as well. Okay. And then you might see all these things like transition monitoring, registering the models and artifacts. All these things will come one by one. So registering data sets, one of the important things, because they will manage the platform inputs rather than informal links. So for improving your reproducibility or the identified data that you want to make it out, for all these things, this is important. So once you do that, object store artifact management will be there. So object store generally, it enables your secure access to the project location. So that is an important bridge between your runtime executions and persistent ML access. So please be aware of that. And then we use a lot of object store based scenarios also on that. So these are the artifacts for the registering models, like as artifacts for that, like your trained models, which are manually registered in SAP Launchpad, which are guided support stored models, which are registration transformations of the raw file outputs, and then govern deployed models, tracking multiple model versions. These are all different artifacts for the registering models. And these are the triggering training executions where you can go from AI Launchpad using these templates. Just have a look on it. So generally teams will monitor this execution and outputs from teams means, like going for this different AI Launchpad teams, right? So that's what I'm taking about. So there is a lot of structured approaches will be there when you're monitoring execution outputs. These are all things comes under that as part of training the models and deployment. So these are the hotel key takeaways for this module. So let me go into the main thing for this. Deploy the custom models via ML workflows. Okay, now let me show you this one. Okay. So now let's start Docker desktop after install here. I mean, we already used. So I'm going to terminal. Okay. So now once you do this, we can do one thing. We can open the BAS environment. We can create some project, create the Python model, create the requirement files and create the Docker files. We can build and push Docker image and create the ML workflow, create AI Core workplace on top of that, and we'll push to GitHub and connect the repo in the AI Launchpad. So this will register a scenario and template. That's where you can run the execution and monitor on top of that. This is a total thing that you can do as part of this lab practice. So I'm going for this one now. Let me open this new window here. BTP. I'm opening the business application studio in this environment. Okay. So once we have opened this, okay, now let's see this. We'll create a thing here. Let's go to this. Okay, we'll create an application from here. This is a full stack Node.js application. You can take it. Cabo 123. I'm taking the application name here. So we have to wait for this application to get generated. If you're seeing here, See here, the versions will be there. So this version specifically, whatever you're seeing this version, let me minimize this. General, which is starting here, full stack. So this status should go from starting to run. Okay. So now let's see here. So we have to wait until it's get running. So let's refresh this one more time here. If you go to this, you will see here, now the full stack mode is running. Now go to the batch project there. Click there. Now go to this, we are in this repo, right? Now in this, we can go to the terminal directly. You can see there is a new terminal. All right. Terminal, new terminal. All right. So this is a new project altogether. Anyways, we can do like this. We can first create a new directory. This is a ML lab activity you're doing, right? So I'm giving make directory ML lab. And I'm changing that the directory also. Same thing here. Okay. Now we open the bash. We have created the project, okay, which is Kbo123. And then we have done the created a new directory, and we are in that directory now, right? So then we have to create a Python model. So directly can we create a Python model? So see here in the file structure, see here, this is the ML lab, right? There is nothing in that, right? Seeing this, there is nothing, there are no files in it. Okay, now create a file, train.py, and then do something on top of. Like I'm doing this one, touch. Train.py. Okay. Now we can see that, see this is created here. Okay. Now let me add. Right. So I created this train.python file. Now add some Python script in it. So double click on it. You will see this one here. I have some script which is ready for me to do this exercise. So I'm keeping that here. That's it. I can see that I'm importing job library. These are standard functions only. Okay. And once after that, I will create one more, which is requirement.text. Okay, now go here, touch requirement.text. So this will be updated here. Now here, simply keep this one. Okay. And then create Docker file, one more file, which is create file, Docker file. Again, go here, touch Docker file. Okay. Now copy this. You will see the Docker file here, right? And put this. And in the next step, you have to build and push the Docker image. So you need what? Docker Hub account. Already we have it, right? So just put this. one here in the main terminal. Just hold on, let it be big here. Okay, now here, or else I'll do one thing, hold on. I will just change here and I'll paste that there because it is not allowing me to do that there. So in our build only, we'll write that one. My Docker ID. Okay, so this one I can copy right there. And I can push it also, right? First build it, don't do two at a time. Just you go to there. First build it, then push it. First build it. Docker command not found. Okay, if it is saying Docker command not found, you can do one thing. Docker version. So if this is still saying the Docker is the smartphone, which means Docker CLI is missing or not in the path. So we can do one thing again. We have to make sure the Docker is running always. So we can do one thing onto this. Let me go into the main terminal here. So into this main terminal. So we can do this. And now this one. Okay, we can do this one. Or as you can do, this means here the Docker is not registered. I mean, Docker, we have to load this. Okay. So we'll do one thing. We will load the Docker in the SAP's bash only. Okay. Usually bash runs on all the cloud connector. So Docker need privileged access for that only. But anyways, here we can do one thing. Okay. For the Docker, I'm just telling you, once the Docker is allowed for you, right? The last step here, what we have to do is we have to just simply keep this workflow of the AML. That's it. Let me tell you that. Yeah. So this is your, let's create one AML file here because I have already shown that one. So touch workflow.aml. This is why you create. So it will be created here, what workflow.aml. And then you can just, in that particular file, we'll keep this one. Okay. And then create all the AI core files like scenario, execution, template. Like, I'm creating all the other files also here. Touch scenario.aml and then execution underscore template dot ml. So these two files we can create. This will be created here. So in the in the scenario, we'll keep this data. And in the execution level, we'll write the execution script for it. Like this one, keep this one. Now we'll finally in the JIT, right? We will push it. That's it. This is what we will do it. JIT init, JIT add. Okay. And then you'll commit that all these things and you will connect to the repo in the AI Launchpads. Okay. That's it. You will run the execution from there directly. So this is what you have to do as part of the AML files. Okay. So now let me check some of these commit statements. Okay. So once you push this, right, I'm showing you here, open the SAP AI Launchpad here. So into our environment, where you want to connect the repo in the AI Launchpad, I'm showing you here. So we'll go to the AI Launchpad. And you can connect from services. Let me show you on the one more service here. This one. So now go to this one. AI Launchpad. Okay, now go to the repositories here. Just check any resource group, that's okay. So you see these repositories, right? JIT repositories. So these are the main ones. This is where Docker registers and everything will happen. So in this, you can add a repository. This is a JIT repository. Add a JIT repository like this. You can add a JIT repository and you can enter the JIT URL, main branch credentials, everything on that. You can register scenario and template and you can run the execution. I'm just showing you how you can do after that. This is the URL. See, that's what I'm telling you. This URL, name, username, access token, once you get that from the system, from this Docker properly, those you can do because it is free, it is not allowing me. But I'm telling you, you can do it little later. Okay. And then you can start, for example, this one is the yeah, same thing we can do. This we can do. I'll just take this one. Okay, but I don't have username and password for that. Okay. So you can try with this one with user and password, and then just this will be done. So after that, you can create the scenarios and run the execution of this scenarios. Okay. So this is how you execute AML files in the build environment. Okay. Thank you.
Hey there! Want to learn how companies use AI in SAP systems? Our SAP AI Core plus AI Launchpad course is here to help. You can learn anytime at your own speed on our platform. In this course, you'll learn all about SAP AI Core and AI Launchpad. It helps you build, manage, and run AI models easily inside SAP systems. Our course covers everything you need to know, from simple concepts to advanced AI tasks. It's created by experts who have real industry knowledge. Your trainers are skilled professionals who have worked with SAP AI tools for many years. They're here to guide you and clear all your doubts. And don't just listen to us. Our learners really enjoy this course too. Students from different backgrounds found this training easy, useful, and great for improving their SAP AI skills. Best part? The course is budget-friendly. You get strong SAP AI training at a price that works for most learners. Ready to become a SAP AI Core plus AI Launchpad expert? Join through our page today. And to learn more, visit ZaranTech.
So we are on the fourth module, which is API integration and generative AI Hub. So in this, we are going to learn about the API consumption, Python SDK, generative AI Hub generations with a hands-on of foundational model generative AI Hub deployment. Okay, with using Python and all these things. So let me start into this. Right, so this is the agenda that we are going to follow this, and we'll understand how to authenticate, call SAP AI Core inference points here, and using Postman collections, and understand how the AP Core Python SDK simplifies, and explore how to create the orchestration deployment, and we'll discover how to manage this reusable prompt templates, and then learn how to embed deployments work and when to use them once an application. So this course was primarily been designed for this integration and generation AI Hub. So it's going into that. So first of all, let's understand what is API consumption and why we need it. Okay. So as we know that API consumption means using the external or internal APIs inside your AI workflows or models to get the data. So sometimes we send the results, sometimes we trigger the actions. So these are all things that covers under API consumption. Okay. In simple terms, if we want to say, let me put my notepad here. So AI model which will calls API and then it will pushes the data that is into continue process. Right. So why we need this, going back to the session again. So here, so why we need this API consumption? Because AI models don't work in isolation, right? So they need business data, they need external services, they need integration with us. So that's where our APIs come in. So where this API consumption happens. Before going to that, so let me show you clearly what is really needed here. So API consumption happens at 3 phases. Okay. So one is your training phase. I'll let you know what is each phase covers here. Inference phase. And the third one will be your workflow steps, which is Argo, ML. Right? So the training phase here, you will fetch the data from SAP systems. Like example, you can take sales data from S4HANA kind of examples you can consider. And inference phase, you can consider whenever you send input, you get the predictions of it. Okay. So that is where you will get that here. And the third phase, which is workflow steps, which is we call it as also Agro ML. So here you will call the APIs between the pipeline steps. So these are the 3 important phases. If you want to give me, like if you want to give us a real example, when you are building a fraud detection model, let's say for fraud detection model, I already told you number of times. Okay. Step 1 will be you will call an SAP API. A step 2, you'll run a model. As a step 3, you will call another API. So which it will generate a fraud alert for you. So now how this work technically, that is what you have to understand. So inside your Python code, it will generate some import request. So let's say your import Python code will look something like this. I have kept a code already for you. So let me paste that for you here. So if you see here, this is a kind of code base for import Python code. See here, import request, response. You will give some API example. You can write any API that is external from your system. That's it. Data is equal to response with dot JSON. So this is an example code I'm giving to you. This is how you have to consume your APIs. Okay. So in ML, this is what I'm giving the Python code. Similarly, you can also call APIs via containers also with ML workflow, which we call Argo. So for that also, I kept a code ready for you. So which is, it looks like, so let me write for this in a differentiation here. ML workflow. So here. Right. So here, you will fetch the data, you will give the container image, and then command and args is the arguments. That's it. So this is a script you call manually whenever you're calling for AML workflow Argo. Okay. So SAP ecosystem integration, generally it has all your API integrations will be there. If you call it for either for S4HANA, either for BTP, either for API, whatever it might be. So if you ask, like what can be a real SAP example, if you take the purchase order risk detection, that is one of the best use case we can quote it out. Like, you can make AI core workflow when it is started, you can call APIs, you can do a model prediction risk, and then finally you can call APIs further. Okay. So that is how you can consume the APIs in the AI core. Now let's go into the next slide. Understand the AI core service key. So what is this? We have a different kinds of API consumptions are there. That is not required at this moment. But let me tell you how you can understand the SAP AI Core service key. Okay, so here as it is been already outlined that SAP AI Core instance on BTP generates a service key, right? I'll just show you that, for example, here, if you are in the BTP environment, so this is our BTP environment, right? So here is where you can generate your service keys. You go to here, see, there's a key here. So you can generate your service keys from here. Okay. So you'll bound to applications. This is the service key where you will generate your service key or create the service key, or you can view the service key, which is relevant for it. So what is the service key here? It is basically a secure credential that is bundled and will let your application talk to your core APIs, right? So your service key is nothing but your username, your password, and your URL plus the token info of the JSON. So any existing keys you can take, you can see that one. For example, I'm just putting that here, a documentation service here. You can just go to this, go to your sub account, then you can go here. Or go to the instances. So you will see the keys here. Take one key. Here, this is your service key JSON. This is what I'm telling about. It includes all your client ID, client password, the URL, everything, whatever I have just mentioned. Okay. So SAP AI Core is basically executed, okay, using your calling of APIs. Okay. So that is about. So your OAuth to authentication flows and AI Core follows this one. Okay. All right. So now we are seeing here, there are many steps are there, right? In OAuth to authentication, basically, the big picture will be, there will be no username and password login screens. Everything happens machine to machine. So what you need here from your service key, you need your client ID, your client secrets, your URL. Just now I showed you, right? The AI URL, all these things are required for that. Okay. So we'll see that as step-by-step flow, what will be done and how can be done in the coming sessions also. Okay, so for now, understand that this is your flow in the SAP AI Core. If you want to authenticate in Postman, you have to set the environment for it. Now, the next, how you call the AI Core inference patterns or endpoints. So how you call it, we'll understand this. Okay, so now here, it's already been told that, like once you authenticate, developers send some post requests and deploy the models, inference points and everything. So I already told you what are inference points in the earlier class. So there is a very practical task. You have already deployed some models earlier. We sent some information and everything. We have done it, right? So this calling AI core inference also, the moment when you get this OAuth token in the Postman, it will create the request. Okay, you will post the methods. You have to write some URLs and everything. So based on that, you can go for a JSON send request and it will call the inference endpoint, either any method, majorly for post method. Okay, so your typical AI URL that will looks like this. Let me give you that as well here so that you'll get the information on this. So your typical, this is the API URL, this is your inference, the deployment ID you're going to do it, and the predictions of. This is the typical URL, how anytime your AI URL, Launchpad URL, deployment URL looks like further. Okay, so further to it, you'll add headers, request body, your send response, everything, whatever it might be. So as a whole, your total API workflow here, it looks like this. Like, from Postman, you have to initiate. From Postman to O token API, and from there to access token, and from there to inference endpoint, and from there to prediction responses. Okay, so this concludes your full flow. So now what the question is, where to get this deployment ID? It's very simple. In the AI Launchpad, if you go to deployment, for example, I'm showing you here. If you go to the AI Launchpad, so we are on this one, right? So in the AI Launchpad, now go to deployments. So you see all these workspaces, right? And just go down. This is your deployments. And your deployment, we have the deployment ID and as well as the endpoint URL. This is where, this is your deployment ID and this is your endpoint URLs further. If you go into this right navigation, you will have everything in this. So like, you can take any real examples, like you can post OAuth token or you can post the deployment. So some real-time post syntaxes I'm giving here for your help, better help. So you can use them further whenever you have the need of, right? So onto this also, sometimes you do some common errors, like, like we'll get errors like unauthorized 401, 404, not found, and all these things you'll get it. So you should not go for any wrong deployment ID, should not make any wrong input format, don't miss any permissions to avoid these errors. Okay. So the best tip is always save token in post environment variables, and then you can use your prerequisite scripts for that, and you have to validate the JSON input format accordingly. Okay. So this is where I can quote some of the real examples also, really, like, when you send an invoice data or when you model the predicts of the fraud detections, when you want to return the risk scores. So all these things are some of the real use case examples for this particular Postman case. Okay. So I explained you detailedly on this. Now let's go to the next slide. Okay. Now introduction to the SAP AI Core in the Python SDK. So all of you know what is SDK. What is SDK? So it is software development kit, right? Right. So this provides what it's been clearly given for you. Okay. So it generally does mean it's a developer friendly library for you, which will makes you to interact with core SAP AI core using Python. So without manually handling raw REST APIs. So instead of you writing something, so I'll just give you some example here. Let me post it up for you. So instead of we writing here these ones, HTTP calls and OAuth headers and everything. So we simply write create client dot create execution, blah, 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 whatever it might be. So this is how it generally goes with. So this simplifies what? Because you are writing this simplified code, it simplifies your authentication, it simplifies your managing scenarios or executions or deployments or listing logs and everything. Okay. So now let's understand why we use SDK instead of Postman or raw APIs. So there may be some kind of scenarios which you have to understand. Let me draw it in a table and show you also clearly why we are going for that. So let's say, for example, we have two cases, which is without SDK and another one is with SDK. All right. So without SDK means what? Like we have manual token handling, and with SDK you have auto authorizations. Okay. Here you have complex REST calls will be there, mean REST APIs. And here you have all simple Python methods. Okay. In a similar way, these are all more for error prone the moment when you use it. And these are all cleaner code strategies. And one of the other important thing I want to add here, which is it is hard to automate. And whereas this one, it is easy for automation. Okay. So like this, without SDK, with SDK, what is the differences we have seen? Right? I already showed you how you can install in the earlier sessions also. Simple, like how you install the environment, this AI core and everything, right? The moment when you open terminal here, like there is a terminal, just giving the instruction for you. You can simply say pip install SAP AI Core SDK. That's it. So this might be done in your SAP PaaS. If this is not able to handle in Mac, you can do it. So similarly, you can add your service case, create your AI core client and everything. So let me try this command in this BAS also. I want to show you this one. Let me copy this. In the moment when you go to BAS, I'm opening the new terminal here. All right. So paste this here and open. Okay, now this SDK itself is not there. What is filling a new release of pip is available. Okay, now let's use this command pip install upgrade pip. All right, so this is happening. See here, right? So this is how you can add this one. Once you have done that, you can load the service keys. Like, you already learned earlier also about this, how to create and what to do in Python and everything. You can do that one by one on top of that. Okay. So, and you can deploy the model and call the inference predictions. Okay. So this is what about your SDK. And going back to here, again to slideshow mode. So we understood this. This is the SAP AI Core. Now authenticating in Postman, setting up environment. Everyone knows that, how you can take that. So these ones also I just told to you. So this is all we have. 1 second. Let me see what is the content that we have earlier also. Okay. Right. Let me go into this one by one. So this is about inference points. Now let's go to the Gen AI Hub. So you already explained about Gen AI Hub in the other modules. So you can refer that. So we can go to the next module here, orchestration deployments in the Gen AI Hub. So orchestration is one of the important activity in Gen AI Hub, as I already told you how you do it in the recent AI methodologies as well. So here it is not just running model or one model here. It's about building the pipeline of Gen AI steps. Like, you prompting, you do grounding, tools, APIs, post processing, you expose it as single endpoint. A lot of things are there, right? It's like full orchestration. So in Gen AI Hub, you define a chain of operation. Either you combine different LLMs, prompt templates, external APIs, business logics, not one. A lot of things are there. So where this basically runs under the hood, like, it executes, runs on AI Core and managed via Gen AI Hub, right? So after that, you will see the deploying of GPT-4 via Gen AI Hub. So I already showed you in one scenario how you do this, and different also there. You can call these orchestration endpoints programmatically. Okay. Either you call from a API or OAuth or any type of application through terminal also you can call it. These are all depends upon different ways that you are going to do it. Okay. And then comes with prompt template. This is very important thing here. So let's understand what is prompt template here. Right. So prompt templates, as you know, are reusable, or I can say these are structured, reusable formats we define to control how input is sent to an LLM, right? LLMs are nothing but your large language models in like GPT, where like machines, right? So they, instead of sending random text each time, we define a consistent template with variables, right? Template means against what? Fixed instructions plus your dynamic input. It's a combination of your fixed plus dynamic. For example, you are a finance expert, you can summarize the following invoice, you give the input of both. Okay. So for which it will replace at a runtime. Okay. So these are all comes under your prompt templates. And why these are important here in AI? Without a prompt template, unpredictable responses will come, system will hallucinate, no control, inconsistent output will come, lot of things will happen on top of that. That is why prompting is very important. So with a prompt template, everything will be organized. Like, you'll have a structured responses, you'll have a control tone, you can use the reusable logic of one to other template, which is enterprise ready, very importantly for that. So that is why you need the prompt templates. Now managing prompts with SAP prompt registry. Why we have to manage only these prompts with SAP prompt registry? Because SAP is having such a mechanism where the prompt engineering was widely enabled for proper Gen AI Hub activities. Like, here, the managing prompts, sometimes called promptee. So this refers to you treating the prompts as versioned or reusable assets, just like your code or models. So they will basically store them in the central registry. Like, as you have already seen, I showed you in the earlier class as well. If you can see this one. So here in the Gen AI Hub, you will see you can see here your prompt management. Here is where all your prompts will get stored in this. Okay. So that is how, you create a prompt, or you go to the editor, everything you see here. This is what I'm saying about. This is the template. This is what you talk about the prompting in the AI. Okay. So this is what I'm showing you also. This gives you versioning. This gives you version control. This gives you traceability and the reuse across the project. Okay. So why managing prompts in registry? Registry is not there. The prompts will be scattered in the code and it is hard to reuse, and there will be risky changes also. That is why, to centralize the prompt, to make a version history, to make a easy rollback or team collaboration, you need this prompt registries at any cost. Okay. So this is like a template, or with variables, a metadata, a version, all these things in one single thing. Okay. The moment when you go here in the Gen AI Hub only, you will see this prompt editor and prompt management. The prompt management specifically, you will see all these 10. Okay. So going back to the circling back there again into this one. So you can declarative prompt management via JIT is also happening there. So these are the different prompt templates in the orchestration. Just have a look on the screen. I'm holding for a minute. So you can see here a lot of templates are stored. It allows orchestration workflows, use the variable runtime substitutions across multiple workflows and decouples the logic. So a lot of activities are there when you use the prompt templates in the orchestration. Right. So then one of the other important topic for us, embedding the deployments. Why we have to embed the deployments? Okay. Embedding deployments means what, first of all? Okay. So when you are deploying a model that converts your text into numerical vectors means embeddings, right? And exposing it as an API endpoint, that is called embedding deployment. So when I'm saying about vectors, the vectors are used quite randomly for your semantic searches, your RAG, your similarity matching, clustering, lot of things are there. Okay. For a simple understanding, it will be like, if an invoice is delayed, you have to know some numbers, right? Some 0.12 minus 0.08, some vectors will be there where they will store your search numbers on top of that, and it will return you some understanding on that. Okay, that is why you need this embedding. So embeddings, why they really matter is LLM don't search database directly. You all know LLM is nothing but you give some prompt, it will search based on the prompt. So it will rely on the embeddings to understand the meaning of it. For example, I am talking, I'm typing payment delay. What kind of payment delay? It's an invoice payment delay, it's a AR delay, or it's a AP delay, what delay it is. If I'm saying late invoice, by whom? So context is missing. So you have to get both similar vectors. System should know they mean similar things. So that is what your embeddings will matter for. So these embeddings generally run onto different ways. Okay, like you can go for create in Gen AI Hub sometimes. You can go for executed by AI Core sometimes. Lot of things are there. Okay. So when you want to create an embedding development, you have to follow this step-by-step process. So let's see the step-by-step process here for creating the embedding deployment. Okay. So in the step 1, you have to open your Gen AI and then launch your AI Launchpad and then keep your Gen AI. I just showed you, right? And then now you have to create the deployment on top of it. Like, you have to create deployment for it, which means you have to configure all your name, resource, and everything for that. I'm not writing everything. So then you have to wait for deployment. Okay, right? You'll be having a status that should go from create to running. Okay, once it is running status, then you have to start. Now, after that, get your endpoint. Okay, you will get your deployment ID, your inference URLs, everything on top of that. Okay, and then it will be completed. Okay, you can call embedding APIs, whatever you want to, you can do it. Okay, for SAP knowledge level, you can do it in different ways. You can use on the user queries, you can convert to embeddings, compare it some stored embeddings, retrieve the documents. You can practice like that. Okay, so this is where. So one good thing is where you store embeddings. I told you, right? It's a common option. Either you do it on cloud as a vector support, or you can do from external vector DBs as well. Okay, so these are the two important things which you have to understand. Where are we storing this particular thing? Always avoid, don't store your embeddings properly, and in a unstoring mechanism, if you are using wrong similarity metrics, the embeddings will fail. Okay, and always the best practice for embedding is you have to chunk your data. That means large document you have to split into small parts. Use the similarities, catching the embeddings, combine with metadata. All these things will help you to make a wonderful embedding responsibilities for you when you're going for embedding deployments. Okay, so this is about embeddings, guys. So these are the key takeaways of this session that we discussed about the inference endpoints. We have discussed about the enablement of Postman from API testing. We have seen SDK, we have seen this orchestration deployments and prompt templates, right? So this is about this session. Let's see what is the practical lab exercise we have in this. So what is this saying here? So the lab exercise we have is deploy a foundational model via generative AI Hub. I already showed you, but I'll show you one more time. Please be on the line. Okay, now step one, we go to this Gen AI Hub, right? So I'm already in Gen AI Hub, right? So this is in the AI Launchpad. Under that, I'm in Generative AI Hub, right? Now we have to choose the models, right? For choosing model, where we go to the model library, right? Now go to the model library, choose one of the LLM model here. There are many LLM models are there, but the standard model we select is GPT 4.0 or mini, whatever it will be there, we can take it. So I'm selecting GPT-4, which is the latest one here. I can go with that. I take this one. Okay. Now, after selecting that, you can deploy this model. See, on the top right, you have the deploy. Just click on the deploy there. That's it. Now, deployment is happening, creating the deployment. So once this is deployed, you can see this one. See, this is the deployed one, which we have done right now, right? So now wait for the status. As I said, right, you have to wait for the status. It should go from created to running. Now it is created only. Now just check the status of it. Now if you go to the cost, in the meanwhile, the properties, everything, metrics. Now go to the model library again. Okay, now if you can see these deployments here, we will see those ones. What are we have done on this? See here, this is the one which I think so we have to see. This is today created on. Current status, target state is running, current status unknown, which is okay. We can go ahead. I told you, right, you should go from created to running. Okay. So you can go with this one. Okay. Sometimes if you are not able, the system's having any issues, it will respond like that. So no need to worry about that. Okay. So then go for creation of endpoint or copy the endpoint of it. If you can take this one, we will have some endpoints in this, right? Take that and copy that endpoint. Now go to the status, scaling, resources, logs, everything. This is still pending. I'll do one thing because many deployments are there might be not taking. I'll take the one which we have already. Now see, this is the endpoint, the URL which you can copy from here. So you should get like this running. Okay, this is the way you have to, system is telling you. Now on the part 2, ensure your custom ML model is ready. A previous thing I have told you, right? How to do that. You can deploy in the AI core first. Okay, you must have deployment ADA like this and you have an endpoint URL. So from your, like you have to go to the ML workflow like this and you have to create your ML workflows also for this. Okay. So after that, you have to generate the service key for this. Like if you go to the BTP download, go to the JSON here. Like if you go here, go to here and get your JSON BTP cockpit. Download the JSON of it. Get the service key of this particular item. Go here. See, this is the AI core notification services. You can take this one, the key, or this one. Some of the keys here, which will take your ID and password. Just install from that. Okay. So once you consider this, now go to the file here and install the library. Whatever I told you, same thing will repeat here also. Your full scripting and your expected output, your full flow of it, the Python scripting, everything will go one by one here. Okay. So I already did the Python installation already done. Okay. I'm just showing here. Go for pip install request. So it's showing everything here, right? Everything is done. Now import request. Import request. So yeah, this is import we can do here. Let me show you this one. These are all we can paste in one single item there, in one single tab. Getting the token. So let me create a file here. Okay, you will see this one, which was being here. So, okay, fine. I have not given .py, right? I can give import py.123. Touch AI dot Python. So now you see the file will be. Let me refresh this page. It's not reflecting. Copy the entire codes, whatever you have here. Okay, now go to the file structure. Okay, this one. It is not creating anything. Now, what we can stop. Yeah, they are getting here. Oh, fine. They are getting hidden here. I don't know. They're not then out of thing. Okay, fine. Anyways, we can copy the code here. Complete. See here, everything is generated here. I kept it keep ready. So this is a way you have to give the full script of, I'm not adding, I'm just showing you because this client ID, secrets, no, when you're trying, it's your own will be there. So you can embed them and then you can use rest of the code will be quite common there. Okay. You can see the inference points where the input payload is happy. You know how this is responding to PRL. Everything is clearly given. Only thing is you have to change this one. That's it. Okay. So this is how you have to build the service key for this. Okay. And this will give you a full output of it. So from Python script to your OAuth token, from your OAuth token to call LLM deployment, and to that you can call the custom model, and then finally you can print the results of it. Okay, so that is the common case where you can take it for this user query. So if you go back to the deployments also, this is what you will see in the deployments. Like you can see here, these are all your deployments which has been actively done. You can see what it has been done on top of that as well. Okay, the status, scaling, and everything on top of that. Okay, so those ones you can see these models also, which were been already been done. Okay, and these are your result feds for them. Okay, so this is how you can actually do this lab exercise. So we deployed a foundation model, as you have already seen. The lab exercise deploy foundation model. So we did it. This is how we deploy it in the main model library. And then we generate hub, we build a Python script. I showed you how to do this Python script also in this application, right? And to query both the custom ML also. From this only you can query that custom ML as well. Okay.
What sets ZaranTech apart in SAP corporate training? It's our unique blend of expertise and innovation. We offer customized courses tailored to each client's needs, ensuring relevant, targeted learning. Our vast trainer database brings you wisdom from the best in the field. Need resources? Access our extensive training material repository anytime. We are all about measurable results, providing detailed student metrics to track progress. And we don't just teach, we build community. Join our thriving social media network, connecting learners beyond boundaries. With ZaranTech, you are not just training, you are transforming your SAP expertise.
Lifecycle management, production operations. So let's discuss about this. So this will have We'll be seeing onto this a simple simulation of model drift scenario, analyze some runtime logs in AI Launchpad, and how to trigger retaining the pipeline to updates and active deployment. So these things we'll be basically discussing. So let me share my screen. So this is the agenda. We will see some of these interesting concepts like AI Core supporting how like the monitoring, scaling security things here, and where AI Launch really exposes the executions and how the exploring of native metrics and how we do the quota planning kinds of things, as part of this. Okay. So first of all, what is the life cycle management? Like, let's understand that. So what is SAP lifecycle management in AI? So that is one of the prime thing which we have to know. But here, see AI context when you are talking about the lifecycle management onto SAP is little different from the SAP's AI lifecycle management. So basically, like it's like like for AI models, right? So here we generally design the models and develop, deploy, monitor, improve, or retire and full journey. Like this is what is structured. Early we manage it. Like this enterprise level governance. For that, this will be very important. So like when we talk about SAP ecosystem, as we have already gone through it, like like we can divide that into like SAP Core, AI Core, SAP's AI Lifecycle, Launchpad, Generative Hub. All these things will come into picture. So AI Lifecycle Management basically, when we talk about an end-to-end process for that, that mainly few things will comes into a picture. Like, you have to talk about problem definition and data preparation, the model deployment, the model development, the model management, the monitoring and observability, governance and compliance, and then there from the continuous improvement. So there are all things will comes into picture when you talk about this particular thing. So this is where, all the life cycle management of SAP life cycle management comes into picture. So let me draft one by one here. So this also covers all your deployment, health, model, quality, and update. So like, AI Core, it is standardizing your execution operations, whereas AI Launchpad, it provides the interface for observing the scenario. So that's how generally this goes with. Okay. So let me unfold this one by one to you. So how you can go with this, and then we can talk about the other things as well. So the first important point, which we're going to discuss here, will be your problem definition and data preparation. So let me open my notepad to explaining more clearly. Okay. So as I said, to the lifecycle management, let's talk about the problem definition and data preparation. Okay, that is one of the important things which we have to talk about. So problem definition and data preparation. So what do you mean by this? Like business problem identification is one important thing. Like, all the data sources, SAP S/4HANA, BW, external APIs, all these things will be there. Okay. So we will be seeing all this, like, data cleaning or the transformation or feature engineering. So all these things will come in picture. So basically SAP Data Sphere and HANA Data Cloud will be tools which you use for this problem definition and data preparation. There comes, we have our next one, which is model deployment. Model development and then we'll deployment. So what is model development here? So when you're talking about this, when you're doing for the Python, TensorFlow, PyTorches or notebooks or experiments, like all these things, whatever you go for tracking and everything, these are all things, comes for the model development, like where we use the integration Git repositories and for a core MLOps and everything. Just let me show you one thing here. Okay, so model development is one of the important things that we go as part of that. Okay, so in this phase, we will, data scientists or they will any kind of AI architects, AI developers, they usually build and train the machine learning models. Like you might use Python framework like TensorFlow, PyTorches. You might run the experiments and compare the models that you can track performance metrics, all these things. So SAP integrates this with version control and pipelines for reproducibility. Like you can create a model that can solve the defined problem effectively at certain times also. Okay. So then next one, let me add the next one here. And the next one is model deployment. Okay. So on to the model deployment. Once the model is ready, it must be deployed, right? So we have to convert the model into a container, okay? Or you might deploy it in an SAP AI Core as well. So you have to expose it as an SAP endpoint also. It depends upon different kinds of categories of what you are going to do with that model on that instance, like what are you going to do with that specifically on that. Like deployment makes the model most useful in your real application. That's what we have to do in the model deployment. And model management is one such thing again comes into a picture. Like after deployment, models needs to be managed, right? This after deployment of the model. The fourth one is model management. All right. So into the model management, like as I said, when we talk about SAP's AI Launchpad, you can track different model versions, monitor the deployments, manage the execution log, sometimes organize the scenarios. So all these things will comes into picture. Basically, the goal is here to provide the visibility and control over all the assets. Okay. And then the fifth one will be your monitoring and observability, where here all, let me write this, monitoring and observability. So where here a model, that means, like we let's say, like what we call to say, AI model generally degrade over time, data changes. So we have to monitor the accuracy, response times, usage patterns. Sometimes we have to take the data drift, model drifts also, and we have to detect the different drift things will be also there. So why this matters is a model that work will initially may become inaccurate later as well. So that is why you have to make continuous monitoring and observability on top of this. Okay. And there comes the next one, which is your important part, which is governance and compliance. So which enterprise AI generally must follow certain strict rules. Like sometimes you have to ensure data privacy, sometimes you have to ensure security, sometimes you have to go for fairness, you have to maintain audit trails, you have to do some access control. So basically SAP emphasizes this responsible AI, especially for regulated industry. So this is where, you need this governance and compliance also. So and the next important one in this lifecycle management will be continuous improvement. Right. So AI is not a one-time activity, right? We know that, right? It's not something you ask, you get it, you shut off the system, not like that, right? So it's retrain the models with new data. You have to automate the pipelines. You have to release the improved versions. So this is all we call under MLOps, machine learning operation, which is called continuous improvement. Okay. So these 7 important things are the part of your lifecycle management of SAP AI. So the main role of generative AI here within SAP generative AI Hub, you will be accessing the foundation models, manage the prompts, build the AI-powered applications. Even for generative AI, the same life cycle applies, like even design, deploy, monitor, and approve. In a simple example also, if we can say the sales forecasting, you need data. So what data? Sales history from S4HANA. You have to train it. What you have to train? The forecasting models. And then you have to deploy it. What you will deploy? The AI Core API you will deploy. And then you have to monitor. On what you monitor, AI Launchpad you will monitor. And then you have to improve it. What you have to improve again? Retrain your periodicity on this particular things. So as a whole, SAP AI Lifecycle Management, which is a structured AI operations that you can see at an enterprise scale level, which will combine your development, deployment, management, governance, continuous improvement, and definition capabilities as a whole. Okay. So this is what you have to understand as part of this lifecycle management introduction. Now going back to our thing, you might see here, there's one more thing here, monitoring in SAP Launchpad. So specifically when it talks about the monitoring in SAP Launchpad, we just discussed, right? So it is a capability to track, to analyze, to manage the health and performance of your AI models and executions also, because that run basically on SAP Core, right? This gives both technical and business users a central dashboard when you go for monitoring in the Launchpad. So this will ensure basically models are working correctly or not in the production, all these things. So what exactly is monitored? your execution. That means your training and inference lines. Every time a model runs, that means a training job or inference request, it creates basically an execution record. So you can monitor the status, the start and end times, the logs and error messages, and all these things that we can execute. So this will help in debugging the failed jobs quickly. In the same way, you will monitor the deployments also. Whenever you are once deployment completes, Launchpad generates endpoints for real-time model usage, right? Like in the similar manner, your deployment is a live model exposed as an API. So you can track the deployment status, number of replicas, resource usage. So this will ensure your model is available and responsive. Okay. And then you have metrics and performance. So you can observe response times, throughput, success failures, all these things as well. And then you have logs also, one of the important thing where you have to monitor. These logs are very critical for all troubleshooting. The types of logs will be there, application logs, system logs, and all these things. So if an API fails in any way, the log shows why, because it is missing input or missing error. These kinds of things you have to show. And not only that, when you go for the monitoring, you have the resource monitoring also, because it tracks infrastructure usage, like how much of your CPU, how much of your memory, how much of the containers. So this infrastructure monitoring, like resource monitoring, this will helps to avoid the overloading and underutilization as well. And then the last type of monitoring you will do is a scenario level monitoring, where the SAP group models into scenarios, right? So where you can monitor all the executions under a scenario. Sometimes we can compare different versions, which is useful for managing multiple models in one business use case. Okay. So as you have already seen, as I show you anyways now in the ML operations window, you will see these scenarios. I'll show you that, once I'm opening the lab exercise for this, you can see that. Now, how the tracking execution metrics natively. So here you might get the evaluation runs in AI Core, which generates the metrics. So that metrics will score the output systematically. So these generally are defined before creating an evaluation configuration, and these will help us to compare models and make process flows. So one thing you have to understand, when we have to go for this metrics, basically evaluation metrics or execution metrics, whatever it might be. See, when you say tracking this execution, we are referring to the built-in, not out of the box, built-in monitoring capabilities provided by SAP. Okay. And also without adding custom logging or external tools. Okay. Like, you might be surprised what are the execution metrics. I has in SAP AI context, an execution means what? A training run or an inference request or an inference job you can consider. So execution metrics are what? They're automatically captured data points, like it might be status, it might be a duration, it might be a resource usage, it might be logs, anything. So these are basically captured natively by AI Core, and they are visualized in the Launchpad as well. Okay. So how this native tracking also works is, like you can, the moment when you trigger a job, okay, that means the training or inference in AI Core, the AI Core automatically records. What it records? It records the execution metadata, execution logs, status updates, and all these things. So SAP AI Launchpad basically fetches and displays this data. So which means what? No manual instrumentation required for basic tracking. So what you can track natively: execution status, pending, running, completed, failed, whatever you want, you can talk about all these things. So execution duration also one of the things, logs, I told you, the resource consumption, execution history. So these are all you can track. These are also, again, we will see under the ML operation scenario execution. So you will see this particular thing. One important thing what you have to understand is what is not included natively here, the important limitation, because native tracking does not automatically include your business or model metrics. Like, it's like an accuracy, it might be a precision, it might be a recall, it might be a score, anything. So for these, you must log them manually in your code. Please remember this. It is not automatic. These ones you have to log them in your code or integrate these external tools. That's the only way. Okay. So that's about this metrics. The next one, aggregated and detailed results. So after execution completes, AI Core generally returns. That means that once it is done this, it will returns what? These two things. So we call it as aggregated metrics and detailed results here, these two things. But it needs more precise, structured explanation in SAP terms. So what do you mean by that? I'm asking. So what happens after an execution complex in AI Core? So when a training or inference execution finishes, SAP AI Core produces these two aggregated metrics and detailed results, right? Aggregated metrics means it will summarize the execution, which means what is the total execution time, what is the final status, what is the resource usage summary, what is the exit code. These are all system generated automatically. And the purpose is whenever you want to have a quick overview of execution health, it will be used for monitoring in SAP AI Launchpad. In the similar way, all the detailed results also will be executed, like execution level outputs. So these generally includes all your fine-grained outputs, which will be produced during the run, like your logs or model outputs or intermediate steps or custom printed values. These are all come from your code, like a print or log statement. So output artifacts are generally stored in these object storages. The important thing which I want to highlight is this. This is because a very common confusion is there. So SAP AI Core does not automatically compute your ML metrics. Whatever the metrics like accuracy or precision, recall loss, everything. These are only available if you explicitly compute them in your code and log them or store them in your code. What I told already, I told you, right? It returns a system system metrics, which is automatic, and it returns the execution logs, which is an automatic capture for you. Okay, so this way, these two things will be happen. It will never return business or model metrics unless you provide them. Please important, make this point as a note. Okay, now how this appears again in the execution step only this will appear. For example, if you are training a job output, your Python script is there. So after execution, it provides what is the status that is completed, what is the duration that was happened, okay, and log of it. AI Core did not calculate your accuracies or your captured what you logged and everything. Okay, one understanding and simple understanding I'm telling you. Okay, aggregated metrics are nothing but system level summaries, okay, which is automatic. Detailed results are nothing but your combination of logs and outputs from your execution. And ML metrics are nothing but they must be explicitly generated by your code. Okay, so this is what you can understand. You can go deeper. There is a very big subject which we can understand. How to store structured metrics and all these things in the JSON, but that is a very big subject. So we just want to summarize this one. I just given enough information for you. This is enough for us. Okay, next one, evaluating model performance continuously. Right? So if you see this, teams can track quality trends by repeating evaluations. Native evaluations make comparisons. Monitoring should be combined. That's what I told you, the executions and all these things, which is important when generating outputs. Okay, fine. So first of all, let's understand what is this evaluating model performance continuously, which means what? Continuous evaluation. What is that mean? It means regularly we are checking whether your model is still performing well after deployment or not just during training. In enterprise scenarios, this is critical because data changes over the time. It's an accepted fact for everyone. We know that, right? And the model quality, because of that happens what? It will degrade. In SAP, this is primarily achieved by combining the AI Core and AI Launchpad, right? So what is this continuous evaluation actually involves? It's like a loop. Okay, so let me tell you clearly also on these things. The continuous evaluation includes you can collect new data, run evaluation jobs, measure the performance metrics, compare with the thresholds, and trigger the retraining if needed, whatever it might be. So these are the things which we generally go with it. Okay. So with this, what happens? So when I'm saying this, let me tell you this. So when I'm telling this, what metrics are evaluated? Like unlike system metrics, these are all model performance metrics you must compute. Like for classification models, accuracy, precision, recalls, F1 scores, all these things will be there. For regression models, I think so, MSCs, MEAE, to all these things. These are all not automatic, guys. Your code must calculate them. So how it works in SAP step by step, I will let you know. Okay. So first of all, in step by step in SAP, if you want to let you know, the first important thing you have to do is you have to schedule evaluation jobs. That is more important. Okay. That is the first important thing which you have to understand. And then we have this log metrics during evaluation, execution. Sorry, evaluation under we can say execution. Okay. Then you have to monitor in Launchpad. And then you detect the model degradation. Okay. Finally, go for trigger retraining. If it's in SAP, I'm telling guys, there's all these things. Okay. Awesome. Yeah. So this one, so when I'm talking about this, in the first one, schedule the evaluation jobs. For example, if you take, you will create a pipeline, which is an SAP core. So you will run it periodically, which is like a daily, weekly kind of thing. And when you want to log, that means this job will takes your new data, runs predictions, compare with actual results. All these things will happen. And then it will log the metrics during execution, which is like inside your Python script, which is an accuracy of something you have mentioned, or printf accuracy, some statements we generally use it, right, from the context of it. So a stored structure outputs will be better for it. Like for example, you have to manually code, I told you, right? So manually code means how you will code like this, some similar script I'll show you here. So you will manually code like this for the Python. This is what you have to give it. So this become the part of your execution logs or artifacts. Then you have to monitor in Launchpad, whether in the launching in the Launchpad, you can go to the executions, open the evaluation runs, check the logs, trends, and all these things. You can do it. Then in the model degradation, you can compare the performance versus previous runs, and you can make a current versus threshold also on top of that. Okay. So then it will give you what is the old accuracy, what is the new accuracy kind of thing. Then you have to trigger the retraining. So if performance drops, automatically or manually trigger the retraining, or you can deploy a new version. So in all this process, SAP handles very good. So the thing, there are some key challenges as well, which we have to know. The input data distribution that will change the session jobs. Okay. And relationship between input output will be generally changes. This is called concept drift. We call it as. So the solution for this is you have to retrain the pipelines also further. And what is that another one? The lack of native ML metrics, which means SAP does not auto track accuracy and anything. You must log them explicitly. Okay. So these are the important things which you have to know as part of the evaluation model performance continuously. So every single thing I'm going deeply because you have to understand. Okay, till the level wherever I can dig it, I'm just digging for it. Now, why systems log matter? We all know everything. Why systems log matter? For guidance in for log retrieval, for errors, for understanding of R&D of those things, any commands or any operational team when they want to review the logs before changing something for the configurations. We needed that, right? The next one is troubleshooting the failed container deployments. So there's a common failure patterns. This is repeated container restarts followed by exponential backup messages. So we can log the log messages, or you can keep it when if it is false, when you can application ever binds. Troubleshooting only should begin with some logs also and all these things as well. When a deployment fails in SAP AI, it usually means what? The container, the Docker image could not start or run properly. Okay, in SAP AI Core. So the key is to systematically identify where it failed. So you can build startup, runtime, or configuration, whatever you want, we can do it. And then there is a step-by-step approach was in SAP generally we recommend. In the ML operation scenario deployments, you can inspect the logs directly there as well. So from there, you can validate the Docker image, verify it, check the dependencies, check the port configurations, and all these things you can do it. That is where all this troubleshooting will come into picture. Next one. In the same way, you'll do the serving deployment failures also. Whenever you key proxy readiness failures, or when serving container masters, they are failing, or any diagnosis that you want on logs also, you can do it on top of that. And operational monitoring workflow. Okay. So operational monitoring workflow, just now I told you, right? This also cover the topic as well. Whatever I have just like detailedly explained you is also cover all these things. Like for the model deployment level, execution monitoring level, how the real time tracking will be, then how the log analysis, root cause identifications can done. These are all covers at operational level. The same concepts will be rerun here as well on that. Okay. And then compute the resource plans in AI code. This is one of the important things which we have to know. So how you compute the resource plans in AI Core? So AI Core offers multiple computing types. Compute resource plans means the infra, basically the CPU, memory, how you do for LS and other things. Right? Similarly, your AI workloads are allowed to use when they run in SAP Core. Think of them like predefined capacity profiles which you can control. So like performance, your cost, your stability, and all these things will be there. So every execution it will runs inside a container. So without limits. One job, one can consume all resources. Other jobs may fail. Cost can increase unexpectedly. Resource plans ensure controlled, predictable execution sometimes. So all things will happen. So what a resource plan contains generally, a compute resource plan generally typically defines your number of CPU cores assigned. For example, one vCPU, 4 vCPU, those things. And memory allocation is nothing but the RAM, which is available for that. And optionally GPU allocations also. And then you have some scaling limits also. Like, you can go for, there are multiple plans will be available, like small plan, medium plan, large plan. So high CPU memory will be there in the larger plans, which will be used for heavy training jobs, and medium plans for balanced resources, which are suitable for standard workloads, and small plans for low CPU and low memory for suitable for testing. So where are all these plans are used? Either you can use for training executions or deployments or inference APIs, okay, and all these things, okay. So yeah, so basically different trainings we can go it, and I don't want to go deep on this. And then metering and cost awareness. So in SAP AI, metering means measuring how much of compute and infrastructure your AI workloads consume. And basically the cost awareness, which means using that information, you can control, optimize, and forecast the spending. So that is especially important in the enterprise setups, like either you use SAP AI Core or AI Launchpad. So metering is nothing but you are tracking the resource usage over the time. So, okay, SAP AI Core automatically tracks this. Like, sometimes the CPU usage, sometimes the memory consumption, the execution durations, number of executions, number of deployed replicas. These are all the inputs which you use to calculate the cost. So what drives the cost in SAP AI? Your cost mainly depends upon the compute usage, the CPU hours, the memory usage over time, the GPU usage, all things will come under your compute usage. And execution frequency also, this depends completely on the number of training jobs and number of inference calls as well. So, and deployment runtimes, how long your model stays deployed, number of replicas you're running continuously, and what is the storage and what is the data transfer cost, and all these things will be there. Okay, so the right size, the practical optimization strategies always go with your two things, which is right sizing and right resourcing plans, and you have to stop the idle deployments. And there you can optimize the code, or you can want to a batch processing, use the scheduling, all these things you can do one by one. Okay, for example, you are using a prediction API. Okay, the poor cost awareness, if you have 3 replicas always running parallelly with low traffic, then you need high cost, low utilization. No, that is not required. Optimize means one replica scale only when needed. So that is called lower cost and efficient usage. So generally, what are the common mistakes people do here is they will leave the deployments running 24/7. That will increase the cost. That should never happen. And over provisioning on memory also, CPU also unnecessarily makes that. And sometimes frequent unnecessary retraining will be there, ignoring the log usage pattern. These are all common mistakes. Okay. So this is what you have to like be very careful. The maximum performance with minimum cost is what you have to achieve. That will happen only when you have the awareness of cost and metering with proper monitoring. Okay. So this is what you have to understand in the cost awareness. So resource groups and quotas, as you already know, I discussed a number of times, these scopes and quotas. And then the planning for scaling. So scaling becomes when you match with the training, inference plans and everything. As just now explained you right now, the smaller workloads may start or basic instances, and you can have a unnecessary compute cost will be increased. This is where you have to limit the quotas, operations and like guardrails for this. Okay. So like this, if you can see this, the security during production operations also very important, because it depends upon your separating credentials, configurations, image and logs and everything. Especially the production security is very important, vital for you. And managing the model depreciation, especially when you're going for continuous deployments and everything, which is much important for you. And you should know the auto upgrades when you have to do, when it will be suited for you, what are the risky and non-risky cases. You have to check with your team by team because auto upgrades use the model version later. So deployments transition will be to newly supported versions automatically. Sometimes your old models might not support if they are doing auto upgrade without knowing the impact. So those might not work for you. So just go with that before you go for the auto upgrade option. Okay. And then the manual version update strategy, it's already, you know, that it will go on time whenever you require. And this approach offers the predictability also. This work well when business approval is required before production rollouts also. That's how the manual version will be working for you. So when you're updating generative AI configuration also, please be careful and have a look on this slide. I already explained you these things in the earlier sessions also. So these are our key takeaways, guys, from this session. So this is one. So let's go into the practical part of it now. So if you go to the instance subscriptions, so the moment when you go for this one, you can see this is what I'm saying, scenarios. Under scenarios, so you will see all these things, executables, created, changing, the monitoring, entire things comes under this. For example, if we go this one, the metrics, you can see the executables, the prompt templates, orchestration configurations, everything. So under scenarios, you will see hello metrics, for example. This one also, you can see this. See how much of executables are there in prompt templates, no? These things it will basically. The executions also you can see here. If you want to schedule an execution, if you want to like this, you can take one scenario. And then, for example, if we go over this one, just select this one. Say next, this is executable. So you can just put the executable one version here. Put text, configure it, schedule it, and review it. So I'm not configuring showing you that right now. Similarly, the deployments and models also. These are all the different deployments, right, which I have showed you earlier also. You can create a deployment or you can run the existing deployment like this. See here, auto-generated, which are running. So initially they might be in created status, but later on they will get running automatically when you open it. Okay, this is how these are the things. You can see the status of it, the scaling. This is what the scaling. This is what I give you an example in the script also. The resources of it. What is the resources? Just have a look on it and just putting the string like this. Okay, in the same way, we have logs also here. Here are now logs to display on this. Okay, on the models also, I can see these are the different models. You can add the model, and in the overview, we get all this. This is what the overview of your monitoring status in ML operations. We can see how many number of executables are there, what are the resource group charts, how many deployments happened, and what are the artifacts of it. No, like these are maintenance charts. These are the resource group charts. Okay, if we go to the operations back to again, you see that. So, and the last one is result sets and other artifacts. You can see there are nothing result set. You can add the result set. You know, any result set. For example, if you want to go for hello world right now, you can add the information and put the URL which one you want to make it out. I'm just writing as example. And you go for this, you go the labels of the scenario, you'll review and add it. For example, if you want to add this, we'll add this. Here is a test scenario like this. So you can test this scenario, the ID is copied to clipboard. Okay, and then you can, these are all the result sets which you can add to, like add it. So see, I'll explain you the result sets also, simply thing. So what are these result sets means, I have explained you earlier also, but I'm just giving you a rethink. These are nothing but, these are the outputs produced by an execution. For, when you're going for a training or inference, this is a kind of output. This will be, can be made available for your inspections or your downloads or further use wherever you want, right? Through the Launchpad, you can do it. Essentially, it's like, what did this run produce? That means the run has outputted what? That's what the result set is. So generally, AI execution run in AI core. You are seeing this Launchpad things, whatever I am running, that running in what? AI core, right? Which means during the execution, your container can produce outputs such as prediction results, evaluation metrics, model files, logs, and everything. So these outputs are captured as logs. They can be stored as artifact. They can be exposed in Launchpad as result sets. A lot of things it can be do it. So this basically contain all your logs, your structured results, whatever I told you, the artifacts here right now, okay? And then the metadata and all these things. So these result sets are not fully automatic. They depend upon your implementation as well, how you implement. So if your pipeline is configured correctly, the file becomes the part of your result set automatically. I just created this as a demo, but if the pipeline is done, this will be automatically be configured here properly on this. Okay. So in SAP AI Launchpad only, you can do this one. You can see this logs and everything also once you are done with this. Okay. We can see the statuses also once you are done, when it is created, what labels and everything. Okay. So data sets also is one such thing which I want to show you here. There's no data set. Similarly, whatever the model, the moment when you go for, see, these are scenarios or the main one for everything in the ML operation. Okay. And these data sets also, let me show you this. So these data sets also, this primarily be purposed for your input data resources. No, they might have your AI workflows used. So when you go for any training, validations and anything, so data sets will be referred to that purpose. So these are not created and managed as a catalog kind of thing in the Launchpad itself, but Launchpad provides the visibility and linkage. While your actual data lives in the storage services here, it will be connected to AI Core. So what does this mean in AI Launchpad is, it's a structured, you can say, or unstructured data by your AI process. It might be a CSV process or JSON file or an image or a document, whatever it might be. So here data is externalized and your execution reads at runtime. That's what the data sets. So these are stored like in object storage for use for your training data and model inputs. Okay. So that's about your total ML operations overview. Okay.
Hey there! Want to learn how companies use AI in SAP systems? Our SAP AI Core plus AI Launchpad course is here to help. You can learn anytime at your own speed on our platform. In this course, you'll learn all about SAP AI Core and AI Launchpad. It helps you build, manage, and run AI models easily inside SAP systems. Our course covers everything you need to know, from simple concepts to advanced AI tasks. It's created by experts who have real industry knowledge. Your trainers are skilled professionals who have worked with SAP AI tools for many years. They're here to guide you and clear all your doubts. And don't just listen to us. Our learners really enjoy this course too. Students from different backgrounds found this training easy, useful, and great for improving their SAP AI skills. Best part? The course is budget-friendly. You get strong SAP AI training at a price that works for most learners. Ready to become a SAP AI Core plus AI Launchpad expert? Join through our page today. And to learn more, visit ZaranTech.